So good morning, colleagues. Good morning, friends of African hydrogeology. Thank you for joining and actively participating in the first Pan-African Hydrogeology Congress. And we are today on the third day and final day. And we're not really clear about how this conference turns out. And we had a lot of uncertainties. Would electricity cuts, power shedding would affect these presentations, and would the turnout be sufficient number, and would we have sufficient abstracts, and who is doing what? We were pretty in a blind. Nevertheless, it turned out to be on the right track. Some excellent abstract submissions, 85 abstracts submitted, and then around 110 confirmed registered participants, and the number of participants exceeded that number. And then some very high quality, excellent quality research going on in African institutions. And this is very promising in many regards. And maybe we'll provide the summary towards the end of the day today. And so the today's session starts by 10:15 Central African time in about 15 minutes from now. Maybe in the meantime, let me give an opportunity to the organizing committee members to say a few words about, introduce themselves, and then say a few words about whatever they want to say about the organization of this conference. May I start from Edward first, and then I'll move on. 2-3 minutes, Edward.
Thank you, Prof. And thank you, everyone. I'm excited about how the entire Congress has turned out. I think it's encouraging, as you mentioned, and also the speakers across the continent, and then also the information that we got from those who don't live here with us but kind of work with us extensively. And that's kind of giving a lot of direction as to what the future research should be heading towards as far as the hydrogeology, physical measurements and all of that are concerned. So I think I'm very, very happy. As I mentioned yesterday, at the time that we put in to put everything together, I'm happy the way it turned out. I think also there's a lot of opportunity for collaboration and also strengthening some of the capacity that we have across the continent. I think in some areas, maybe we may have some particular strength, in some regions which can be transferred to other places to keep the research work going. So overall, I would say thank you for the opportunity also to be part of the organizing team, and for your leadership and encouragement, and all the team members say thank you. Every single email that you send in response to any of the correspondences that passes by is very encouraging, and I would say that we will keep the spirit and then also see how we can move the association forward in a very vibrant way and recruit more young people who will continue to do quality research across the continent. Maybe a lot of thanks also to Olivia, Lydia, and Behailu, and Piet, and everybody. Thank you. Thank you all.
Yes. Thank you so much, Edward. If you could introduce yourself, let's say, in 30 seconds.
Okay, so my name is Edward Bam. As you see, I'm an assistant professor at the Mohammed VI Polytechnic University here. I'm a Ghanaian by birth. Yeah, and I'm an isotope hydrologist and a hydrochemist. I'll put it that way. Thank you.
Okay, thank you so much. And Lydia, maybe Dr. Lydia Olaka, if you could say a few words and then introduce yourself.
Uh, Yes, thank you so much, Professor Seifu, for giving me this opportunity. And also thank you to you for having the vision of having this kind of a congress to bring Africans together who are working in hydrogeology. I am very excited about the outcome or the response that we got from the continent, and it shows that there's quite a lot of talent which is around, and also the need to connect people. I think most of the times we do not have a lot of congresses or conferences that connect Africans. We have mostly north south, north south. So, but it's really important to have this strong network to know where the strengths are in terms of technical strengths in hydrogeology, and also where the gaps are within the continent. So this particular conference has come at a very good time to enable us to do that. And I'm also excited about the survey that that is ongoing, and what we are going to discover from that, because that can help us then to chart a way forward. So I also thank the organizing committee, the members who were with, and we worked together. Everybody was really selfless in ensuring that this happens at this particular time. And you also thank all the members all the participants who were interested in presenting. Some we were not even able to present because of the time, but we hope that they will stay in our network and we'll be able to grow this particular network. So in conclusion, my name is Lydia Olaka. I am a lecturer at the Technical University of Kenya. I was at the University of Nairobi before, so sometimes you'll see my affiliation as University of Nairobi, but I'm now at the Technical University of Kenya, and I am a geologist, but I do also geochemistry and also paleoclimate reconstruction. Thank you.
Thank you so much, Lydia. Maybe Cynthia, if you could introduce yourself likewise, Cynthia.
Good morning from this side, and I'm also Cynthia from Ghana Atomic Energy Commission. I am an isotope hydrogeologist and also a member of the organizing committee. I would want to apologize for being very quiet and silent due to very personal issues I was going through, but I've been following the emails, and I'm glad that I joined. And I'm also happy to see the turnout, especially the participation, the presenters. Like Edward and Lydia said, this is one of a kind, because normally we have conferences that is north-south, and this time it is focused on Africa. So we are able to tell the kind of research we are doing and what the gaps are, what we really need to focus on. So it's very encouraging to see the kind of works we are doing and what needs to be done. I also like to thank Professor Seifu for his leadership in all this, getting all of us on board and not giving up on some of us and making sure that we get this done. So thank you very much, and we hope that we're able to organize another one in future where we see more progress in terms of the continents, the kind of work we are doing in the continent. Thank you.
Thank you so much, Cynthia. I really appreciate it. And then Behailu and then Piet, in that order.
Yeah, hello everyone again. I am Behailu, a hydrogeologist based at Surrey University. I'm also representing Water and Land Resource Center here. Honestly, I would say this is historic, literally historic. The first Pan-African Hydrogeology Congress was a vision by Prof. Seifu, and I'm happy to be part of this. And it has always been a pleasure to have you, Prof. And I'm happy that I'm sharing that vision of yours. I'm honestly enjoying the Congress day by day, like the first day, the turnout, and the opening remark by Dr. Khalis, like positioning groundwater in the African water vision. It was a very good way of framing our agenda in the Congress, and that compelling presentation by Prof. Dan Olago showing us the challenge and opportunities. It was really amazing, and all excellent presentations by researchers from different parts of Africa. Day two, I mean, it's been an honor, like to be part of the speech, the keynote speech by the distinguished Professor Alan MacDonald. It was really interesting presentation, and the speech by Prof. Grant Ferguson, like challenging us in a way to rethink in many of the things that we think we know, that we have perceived so far. It was really amazing presentation, and that excellent high quality presentation by different researchers continue to happen, and in every minute, every second, like looking at the motivation and the different perspective of research in different parts of Africa it was really amazing. Like you said, there were many uncertainties, right? When you first brought it on the table, there were a number of uncertainties, but it doesn't look like this is the first one, right? So, I mean, the way people were reacting from the first post in LinkedIn, then a number of abstracts submitted, and everything was really amazing. I was looking at the survey last night. There are really, it was definitely a quick assessment. There are a lot to do in the future, but we will present that today. And there are really interesting things to start with. And I was saying that yesterday that the next Pan-African Hydrogeology Congress, I wish it would be in person, more engaging. It was good to start virtually because of many obvious reasons. But I hope that we also need to work hard to make it physical, like in person Congress for next time. I hope that we have already inspired by all the motivations that we have witnessed, and I believe that it's possible to continue this first historic journey, and it will be like one of the legacy of Professor Seifu, I would say. I hope that you will also continue supporting us. I'm really, really happy and privileged to be part of this organizing committee. Thank
Thank
you.
you so much, Behailu. Yeah, Piet, and then I could also see Prof. Anthony in that order quickly. Yeah, we're meant to start now, but please introduce yourself, Piet, and then Anthony, Prof. Anthony.
Thank you so much, and good morning, colleagues, and good morning, Seifu and the rest of the organizing committee. I'm very excited to be part of the organizing committee for this historic first Pan-African Hydrogeology Congress. I think to me, Personally, it has been an honor to serve with colleagues from different parts of Africa. We handle different elements and components of hydrogeology change behind the scenes as we are planning for the Congress. I've really learned quite a lot from both of you under the leadership of Seifu and Behailu as well, and the rest of the committee members. I think reflecting on the program itself, I think I have, in addition to what others have said, I particularly liked the inclusion and the presentation by the government officials, because in congresses like this, we normally miss them to make their impact, because they're really doing quite a lot in terms of practice. They are the ones that are supplying the communities with groundwater. But I particularly liked their presentations, starting from the good techniques that they are using for groundwater exploration and test pumping and many other important components of hydrogeology. I think going forward, me as well, I would like to see participation mostly of the young professionals as well as part of mentoring. I know that they are in this program, but I think we can do much better. And we reflect that we can also be inclusive, the issues of gender as well. I think that's where we are going, colleagues. But in its entirety, for the first edition of the Congress, I think it's to me it's a highly successful Congress, and I wish us we can do more for the continent, and this will lead us to
Yeah, thank you so much, Peter.
in different parts of our countries future.
Yeah.
And in conclusion, as others, the University of Botswana might hydrogeology in my practice as committee, and I hand it over to you. Seifu.
Thank you so much, Piet.
Hello, Seifu.
Yes,
All
I
right.
could hear you. Thank you so much, Piet.
Over to you. Yeah, thanks a lot.
Yeah, let's move to Prof. Anthony, and quickly, Prof. Anthony, we'll have to start now.
Okay, good morning. Thank you very much, Prof. Seifu. Fortunately, I joined in late, so I was a little bit, I was thinking about what's going. Yesterday, unfortunately, I had a family issue to deal with, so I couldn't join. But generally, I have also been quite impressed about the whole thing and the opening of this Pan-African Hydrogeological Congress. I believe it's a very, very good initiative that if we are able to continue will really help most of the hydrogeologists, the institutions that are offering these courses, a lot of network opportunities. I believe that, hydrogeology in Africa is advanced, but sometimes we find it difficult to know how these things are organized in other areas, other regions, and other countries. Groundwater doesn't really have boundaries, as we see countries do have. So it extends beyond our borders. And for me, networking is one of the most important issues that we can help bridge all the gaps and help ourselves. So my take would be that with this thing that has opened up, we can continue with it and improve on the network opportunities among colleges and institutions that offer hydrogeology, and also the people, hydrogeologists themselves, and also help the young ones, as a previous speaker said, the young hydrogeologists that are coming up have a lot of information, knowledge, and the things, so that our thinking will be opened up broadly across the whole continent. I am just hoping that, that we can continue with this. Thank you so much for all the efforts that you've put in, and all the organizing committee, the IH, helping us open up this. And I think that the best thing for us to do is to make sure that we don't lose this sight and continue with it. Thank you very much.
Thank you, Prof. I really appreciate. And there are a few other organizing committee members who couldn't join us now, but will join us during the day. Dr. Saina Poussisse from Senegal, University of Anta Diop, and then Noel Alfara from Belgium and Libya, who could not join us for family reasons, and Dr. Maha Abdurrahman from Nile Basin Initiative and Sudan. She is currently now traveling, and then she couldn't join us. Probably she'll join us during the day. So thank you so much, colleagues. And then last but not least, if it was not because of Olivia, it was tough for us to organize this. And Olivia, maybe would you want to introduce yourself briefly?
Yeah, I think my camera's working today. Hi, everyone. My name's Olivia Fraser-Cobbett, and I'm Executive Officer at IAH. I work part-time for IAH, and it's an absolute honor to be here and to support the Congress today. I have a master's in hydrogeology myself, but these days I'm working for IAH part-time and spending the rest of my time on different things. So yeah, it's a great honor, and I'm really happy to have supported this and to be here today as well.
Yeah, thank you so much, Olivia. So we start our program. If you could show the program for the day. And then by the end of the day, we'll have the AMCAO representative and AMCAO water director, Mr. Rashid, who will give us concluding remarks and closing. And so let's reach out to our colleagues to come and join later this afternoon as well. And then, so this is a program of the day. And then Zita, Cynthia, and Kate, who are going to chair this. Cynthia,
I think it said
Lydia.
Anthony as well is
Anthony.
hosting this morning, if you're happy to do
Yes,
so.
so please let's go ahead flexibly. And then, yeah, whoever wanting to volunteer to chair, maybe start with Cynthia and then Anthony, and we go forward.
Do we have our first speaker on? Yeah, we can see your screen now. If you can put it in the presentation mode, then that will be okay.
Okay, I'm trying to do that. Okay, so do you see it now? Okay.
Good, great.
Yeah, thank you very much indeed.
Yeah, so you have 15 minutes to do that, right?
Sure. I am presenting on assessment of heavy metals in shallow aquifer boreholes as a possible contributory factor to rising chronic kidney disease cases in Maiduguri and environments, Borno State in Nigeria. I'm Professor Goni with the University of Maiduguri. Of course, Seifu and other colleagues that talked yesterday, Alan and Vicky, are all at some point collaborated in some way. Seifu just came in as I'm living Abidjan. So nice seeing you and well done for this very important initiative. So I'm presenting on behalf of these colleagues that are there. You can see them, the team that did this work. And by way of introduction, is to understand that heavy metals at low concentration may be useful or essential to human health, while in excess, it can have severe negative health effects. Heavy metals are released to groundwater resources of an area through natural processes and anthropogenic activities leading to contamination. The groundwater is the major source of fresh drinking water all over the globe on account of its relative good quality, largely requiring no treatment. Supply of safe drinking water is crucial to human life, and thus its quality should not impose significant risk to human health. In the Libyan environment, groundwater from shallow aquifer is the dominant source of drinking water supply, and it is the most susceptible to pollution on account of its shallow depth unconfined nature, and poor waste disposal systems in the area. Thus, we need to assess and monitor heavy metals concentration in the shallow groundwater of the area that may contaminate the system from anthropogenic sources. The study aims at evaluating heavy metals concentration in groundwater from shallow aquifer boreholes in Maiduguri and environments, and to assess potential health risks to kidney diseases associated with its consumption. This is about showing the geological map of the Chad Basin, with Maiduguri somewhere here, largely underlain by the Quaternary Chad Formation. And to their right-hand side is a cross-section showing the major aquifers of the Chad Formation in Maiduguri. You have the upper aquifer, which is the focus of this study, but we also have confined middle and lower aquifer at considerable depth. The middle aquifer is about, the middle aquifer is about 250, 350 meters, and the lower aquifer is greater than 500 meters. In terms of methodology, I said a total of 300 groundwater samples from shallow aquifer boreholes were collected for heavy metal analysis in 2022. At each site, coordinate elevation were measured, and a portable sensor is used to measure the pH, temperature, EC, TDS, redox potential, and dissolved oxygen at the site. Sampling was carried out following standard quality assurance protocols, where 3 replicate water samples were collected and labeled in 3 clean plastic bottles. Prior to collection, bottles were rinsed 3 times with salt water and kept in cool box during field campaign and sent to the lab for analysis immediately after that. This is the study area now, and then the distribution of the sample. As you can see, they are all samples from boreholes starting the upper aquifer of the Chad Formation. And we have, as we said, sample about 300, collected about 300 samples for analysis. Results now, result presentation. Here is the pH over the study area. The pH we said is slightly variable across all the sites, but mostly close to neutral, although we have few clearly acidic and basic samples that we see with low pH and quite close to 8 pH in terms of the basic one. We collected the TDS and the EC samples, and a plot clearly showed the linear relationship between total dissolved solids and EC. And then to the right, these are plots of individual measures of the TDS in milligrams per liter and EC in microsiemens per centimeter. What is important is that most of them are below 500 in terms of the EC, and then about 200 below 200, but we clearly have some few areas with 800 to 1,000 milligrams per liter TDS concentration. And those high values of this EC TDS possibly indicate pollution. For the heavy metals, which is the focus of this study actually, we said results of 6 heavy metals, lead, arsenic, copper, chromium, cadmium, and mercury, are presented with percentages of concentration above permissible limits of the WHO or the Nigerian standard for drinking quality, which is NSDW2. These heavy metals are considered because they have been reported to have direct effects on kidney diseases. The results now, clearly what we did in the presentation here, we look at the permissible limits by the WHO or Nigerian standard, and now classify our results into green or red, depending on whether they are within, below the permissible limit or above that permissible limit by the WHO or the Nigerian standard. So here, And we have the percentages in yellow here. So we said the result shows that no groundwater sample in the study area has concentration of mercury, as you can see in the left-hand side, which is all green, and only one for copper, which is the one red above their sample, that is above the permissible limits of the WHO and NSGWC, the Nigerian standard. And therefore, we said consumption of groundwater from this borehole, based on these two heavy metals, therefore, may not be a contributory factor to the rising CKD in Maiduguri and environment, because we have 0% for mercury and 0.3% for copper, which is largely they are free of those above the limits that is set by the WHO or Nigerian standard. However, when it comes to the other metals, arsenic is about 18%, cadmium is about 23%, and then we have lead about 48%, and chromium 56% of the samples are above the WHO or Nigerian standard. So we said here that's the explanation. In the case of arsenic, cadmium, lead, and chromium, the percentages of concentration in the borehole above the WHO and Nigerian standard permissible limits for safe water are variable from 18 to 56%. Thus, consumption of water from this borehole may be a contributory factor to the rising CKD in the Maiduguri environment. But if you look at it also, what is important is that their distribution, spatial distribution, tends to be across the whole area. There is no bias in terms of areas where you have high. It means it's just all over the study area, they are wide distributed. So we said, although it may not be the sole factor, because the fact that there is no bias in the spatial distribution of these high heavy metal concentrations, while CKD prevalence reported in Maiduguri environment is biased to somewhat. Here we observe that looking at the reported cases or diagnoses, it appears to be somehow biased to some certain wards. But if we see this distribution of the metals, even those that have higher concentration above the standard limit, permissible limit, we see that they are widely distributed and they are not biased to certain locations. And therefore, we're saying it may be contributory in this case before of this, but their contribution, there are other also factors that may lead to the CKD in Maiduguri and environment. So by way of conclusion, we say a total of 300 samples of groundwater from Abeokuta boreholes were analyzed for 6 heavy metals. Results show that concentration of mercury and copper are below permissible limits for safe water, and therefore may not be the cause of CKD in Maiduguri environment. However, the concentration of arsenic, cadmium, lead, and chromium in some of the boreholes are above the WHO and Nigerian limits for safe water. Thus, consumption of water from this borehole may contribute to the rising CKD in Maiduguri and environment, though it may not be the sole factor responsible for that. We'd like to acknowledge that this work or research, we have a grant from the Borno State government looking at the rising cases of CKD in Maiduguri. The government says, can we look at the upper aquifer, since we feel is the one that is quite susceptible to pollution, and see whether heavy metal concentration, evaluate those and that. So we appreciate the state government, and in particular, we appreciate community leaders and especially individuals that granted us access to their borehole for sampling. Thank you very much for your attention.
Thank you, Prof. Thank you very much for your presentation. Do we have any? You have a few minutes left. I think you managed to do that within good time. So we have about 4 minutes or so for questions and a little more. So Lydia, I can see your hand up. Do I want to ask a question, please? Go ahead.
Yeah, thank you, Professor Goni, for your presentation. and also good that you present quite a large data set of the area. I just wanted to follow up and ask two questions. One was the water sample that you analyzed mercury in collected separately, and how was it collected? And then the second thing is about the sources. Would you say something about the source of the contamination? Is it natural? Is it clustered around mining areas? Or what is the source of the contamination of the heavy metals? Thank you.
Thank you very much, Lydia. That's a very, very good question. In terms of sampling, I think it's the same sample we analyze. What is clear is that mercury is not, the concentration of mercury is quite below the permissible limit for both the WHO and the Nigerian standard. How do we collect sample? All samples are collected at the same time. It's the same sample that is analyzed for all the 6 heavy metals that we presented here. So there's no separate analysis, separate sampling rather. In terms of the source, this is what we are going into in the next phase of this work. That what then are the three now attributes, especially for the higher concentration? Can we look at are they related? There's nothing, no mining activity going on. And therefore, we feel that we are looking at in the next phase to look at how is it, how are their proximities to like waste disposal sites, because these are at the center of Maiduguri, and Maiduguri is the capital of Borno State, and you have a population of over 2-3 million people there, and there are lots of waste disposal sites, and therefore we look at the waste disposal site, we characterize even the waste that is generated, what are the possible, and then we are also interested in looking at like mechanic workshop, battery, so that the lead, is it related to this sort of anthropogenic activities that led to some of this contamination. So this is the next phase of the work. This one is just to say that because there's rising case of CKD in Maiduguri, and therefore the idea is that is it coming from the water or is it coming from other sources? And we know that most of our water is coming from this shallow system, and the shallow system are prone to this anthropogenic pollution. And that's why the first layer is just to assess that, and the next level is now to say where are these heavy metals coming from? Are they geogenic or anthropogenic? If they are anthropogenic, what are the clear this? And even the next level is then how can we attenuate, how can we degrade some of this? Thank you very much indeed.
Okay, yeah, thank you. Maybe just for, again, follow up on the mercury, sometimes I think with some of the experience, especially when it is collected in a plastic bottle, sometimes it doesn't hold very well. So probably it would be something to just check again if you're planning to sample again, to compare, sampling it in a different, especially like a glass bottle, and then see what kind of results you find, or the concentrations that is found there, because mercury is more oily, so sometimes it tends not to be seen very well when it's collected in a plastic bottle. Thank you.
Okay, thank you very much. That's a good suggestion, and we have not thought of it that way, so this is additional. Maybe next time, even if it is on isolated, on some small scale basis, we will collect it on glass bottles, and then compare the result, do the same analysis, and see if we can get different results out of it. Thanks a lot, Lydia, for that.
You're welcome.
Thank you, Lydia. Do we have any other question for Prof. Goni? Yeah, I can see a hand. Okay, Umar Hassan, please go ahead and ask a question. Umar Hassan, please, your hand is up. Do you want to ask a question?
Okay, I have one question.
Good. Go ahead.
For presentation, it's very appreciative. Depending on that, one question. My question is here that is there any variation of these heavy metals in confined and or unconfined aquifer? Is there any difference or variation?
For now, we concentrated on the child system. That's why we are going into the next phase would be now looking at because there are very few boreholes that are tapping the ecosystem. As I said, majority of the water supply is for that. And the government interest is looking at that. That's why that is the focus of this. But sure, we are looking at the deeper confined aquifers that we have. As I have shown, we have two other layers, the middle and the lower aquifer, at over 200, 300 meters below ground, and the lower aquifer even below 500 meters. And we have some boreholes that are tapping that, though limited. Maybe one other thing that we'll do is to look at whether these heavy metals are at the same concentration there. And these are the sort of things that we'll evaluate, that we are looking at for the next phase to evaluate what are the sources. Now, because if they are not in the lower aquifer, then definitely maybe since we are dealing with the same geologic formation, then it's not geogenic. Therefore, we then focus on the anthropogenic components. What is the waste disposal site? And even the concentration of these metals that we evaluated, how are they spatially related to some of these sites that we know that are doing a lot of battery activities or mechanic or even domestic waste, solid waste disposal. These are the sort of things we will go into in the next stage of this work. Thank you very much, Shua, for your work. We do have that.
Thank you very much.
We can take the last question from Kafula, and then we go to the next presentation.
Hello.
Yes.
Hello.
Please.
Good. Thank you so very much, Prof, for the insight presentation. I've got a question on the age of the water in the aquifers. Did you consider doing the or measuring the age of the water in those aquifers as well as part of the parameters that you do? Thank you.
Sorry, again, are you saying, did we consider the age of the water?
Yes, in the aquifers.
Yeah, in terms of age, we know that the upper system is the one that is being currently recharged as annual recharge, while the confined systems are quite old water that are not, have very limited present day recharge. But yeah, beyond that, we know that they are being currently recharged the upper aquifer system. So in terms of age, it's quite young compared to the middle and lower aquifers in this area. I don't know if that answered your question.
Yes, thank you so much, Prof.
Okay, thank you very much, Prof. I think we can move to the next one. I can see that Bertil Nlend Yvon is ready. Maybe that will be the last presentation for the break. And if Bertil is ready, please share your screen and go ahead with your presentation. Thank you.
Yes, good morning, everyone. Can you see my screen? No.
We can hear you and your screen is just loading. Just switch to presentation mode and then you'll be ready to go. Thank you for stepping up.
Right, so you have 15 minutes.
Okay, I think it's okay. Okay, thank you. Good morning, everyone. Thank you so much for organizing this. Thank you all for your presence. I am Bertil Nlend. I am in Cameroon. I work at the University of Douala. This presentation I have to give, I change a bit. It's from a project we had in the Sahel region, in the Lake Chad Basin, a project supported by the International Atomic Energy Agency. And this project is about the groundwater functioning and in this part of the Sahel region. And I will present on behalf of all my team at the University of Douala. So the presentation here, as I said already, concerns the Lake Chad Basin. The Lake Chad Basin occupies in this region a great place in the Sahel region. It's about it occupies a great surface in the Sahel. It's about 8% of the African continent. We had an important population in the region. You can see that in this slide that the population growth rate is about 2.5 and 3% for year during the last decades. And this region, the issue here is that the region is already undergoes many issues related to global change. When I say global change, it's about climate change and also urban pressure, important population growth. And the fact is that it's a basin where we have to share water resources. And I will talk mainly here about the groundwater and the regional quaternary aquifer, which is the most important shared water resource in the region. This quaternary aquifer is used for drinking purposes, agricultural purpose, for breeding, and also industrial uses. So we have in this region a great interest in groundwater resource and a great interest in the quaternary aquifer, which is a regional one. And in this project or in this presentation, the goal was to understand the aquifer functioning in terms of recharge, in terms of groundwater interaction, in terms of relationship of groundwater with surface water. And the second goal was to discriminate the different contaminants or to identify the different pollutants in the water resources. Yes, so this is the two objectives of this work. And at the end, the plan is to propose some kind of strategy to manage the groundwater resources in this region. So to achieve this goal, we design methodology from sampling to lab analysis. We sample groundwater, surface water, both in the basement and both in the quaternary, which is sedimentary aquifer. Analysis was concerned major ions, stable isotope, and also tritium. And to identify the different contaminants, we also perform analysis of isotope of nitrate, 20 sample, I think, yes. So this is the methodology, simplified methodology. And concerning the result, I will present directly the result, where here we have the deuterium oxygen 18 diagram, where we can see that we have a great heterogeneity in terms of isotope signature. We have different sample in groundwater. Groundwater concern the sedimentary part and also the basement. We have sample in the surface water. When I say mayo here, mayo is about surface water who are not permanent, which are not permanent. And yes, the Logon River is the most permanent river in the region. So here from this graph, we can see that we have depleted groundwater, maybe paleo groundwater. This is the first hypothesis. We have groundwater which are also depleted. We have groundwater more enriched, and you have groundwater close to the surface water part. And let me show the next slide. In the next slide, you have here the elevation, the map of elevation in the region. And for this group of groundwater, we identify that this groundwater are depleted, but close to the rainfall signature. And this kind of groundwater comes directly from the Mandara Mountains in this part of the region, in the most elevated part of the study region. So this can correspond to a mountain system recharge in this region. And in the next group of sample, around or directly more close to the rainfall signature, this can be identified as a diffuse recharge or a direct infiltration of rainfall to the groundwater system. So this corresponds to a diffuse recharge. And the next group, the most enriched sample, correspond to a focused recharge where we have some groundwater sample more close to surface water. And the third one, where we have sample from the quaternary and also from the basement, are apart, more depleted than all the group, maybe can correspond to paleo groundwater sample. So we have different kind of recharge in this area. We have a focus recharge where we highlight and influence an interaction between surface water and groundwater. We have a direct infiltration of rainfall in the groundwater system, and we have a mountain system recharge thanks to the Mandara Mountains in the western part of the region. And it seems that we also have a ancient recharge in the region. So this is the first result, the first information we have here, thanks to stable isotopes. In the next slide, I present now the Piper diagram, where you can see that the heterogeneity we observe in terms of stable isotope is also observed here in terms of chemistry. We have different kind of water types. We have different water types. We have different water type, and we can see that most of the water type correspond to calcium bicarbonate and also calcium chloride. Yes, and we have this one, which is where we can see that the presence of sodium is most important. So what is the information from this slide? We move from stable isotope to this one. The first information is that there is a great heterogeneity. There is no homogeneity. Yes, there is a great heterogeneity. And this heterogeneity reflects what? Maybe we can see this in the next slide. In this next slide, we also observe this different water type here in this Gibbs diagram. Yes, we have this sodium bicarbonate water type more close to a pole of rock dominance, the calcium bicarbonate water type, and the last one, where the sodium is most abundant, correspond to calcium chloride water type. So, hypothesis we can bring here is that we don't have a sample which reflect the precipitation dominance. We have this sodium bicarbonate water type, which must correspond to maybe this paleo groundwater, where the interaction between water and the rocks is most important, due maybe to the residence time of groundwater in the system. We have the calcium bicarbonate water type, which correspond also to an intermediate phase between geogenic process and maybe also influence of anthropogenic activity, which is most observed for this type of groundwater, calcium chloride. And when we put together isotopes, here we want to confirm all this process by using tritium and oxygen 18. In the first graph, we have tritium and oxygen 18. We can see that we have different flow paths in the system. You have the first one, which maybe will correspond to the shallower groundwater, where the oxygen 18 are the most enriched. We have an intermediate flow path where the oxygen, the isotope is intermediate between the signature isotope, stable isotope is intermediate between the most enriched one and the one which is maybe more depleted. So we have the shallower groundwater flow path, an intermediate flow path, and a deep flow path, maybe which correspond to the sodium bicarbonate water type. And the next diagram about carbon 14 and carbon 13 confirms that we have in our regional quaternary aquifer system a deep groundwater which refer to, I don't know if I can say paleo groundwater, but it's recharge which is more ancient than what it's modern, I can say that. So we have this radioactive isotope confirm that we have a recharge which is more ancient than the modern one in the system. And this And this paleo groundwater or ancient recharge which will refer to this sodium bicarbonate water type that we observe. And in this slide, when we combine oxygen 18 and electrical conductivity, we can see that we have the confirmation of these different flow paths in the system. The shallower one is where we have higher content of electrical conductivity. Electrical conductivity is very high in this system. We have the deep flow path, only maybe few points, but we can see that in terms of isotope, they are the most depleted, and the electrical conductivity are not low, even high, but confirm that we have here a great residence time, and between the two flow paths, we have an intermediate one. So this is the main message here concerning the functioning of the regional quaternary system in the Lake Chad Basin in this part of Cameroon. So the next slide, I'm almost at the end. This concern, here we want to talk about groundwater contamination, which is an important concern in the region. We have two maps. The first one at the left shows the nitrate content in the region. This is a the map shows the spatial evolution, the spatial concentration in terms of nitrate in the region. And we can see that at this time, in 1992, nitrate was mainly between 0 and 10 milligram per liter. We have here in all, maybe almost the region was in the blue part. Now, when you move 3 decades ago, 3 decades later, we have here, now you can see that the nitrate concentration increased, maybe multiplied by 6. The blue disappeared. We have now content of nitrate which can reach more than 200 milligram per liter. So we have a great anthropogenic influence. We have a great concern about nitrate contamination. And the issue or the question is that this nitrate originate from where? What is the origin of this contaminant in the groundwater? This is why we use finally isotopes of nitrate to investigate, to begin, because it's just the beginning, to begin to investigate the origin of nitrate in the systems. And we can see that we have the main sources of nitrate is that these contaminants come from manure and septic waste. But when we see, if you want to make a zoom, you can see that maybe we will have some points which will belong to nitrate, which will originate from nitrification in the soil, and the other one from manure or septic waste. And the other information here is that we have an important denitrification process that we need to investigate in the future. So, yes, there is a problem of contamination. The next phase, maybe after this work, is to better investigate the origin of contamination, is to better investigate the denitrification process in our system. So, yes, if you want, what is the take-home message for this presentation? Is that in the Lake Chad Basin, in the southern part of the Lake Chad Basin in Cameroon, concerning the groundwater recharge, we have currently an active groundwater recharge in the system. We have a contribution of surface water. We can see that we have some point enriched close to surface water. We have diverse recharge mechanisms, and the important point is that we have a strategic groundwater resource. It is strategic because we can see that this groundwater is the most depleted in terms of isotope and correspond to what we can call here paleo groundwater. And the second take-home message is about the groundwater flow path. We have different groundwater flow path. The deep one is more protected from surface pollution, having different water type. We have a shallow one which is more affected by water pollution. And between the two, we have an intermediate flow path. And what we can recommend is that we should take care up on the paleo groundwater, which is not undergone a modern recharge. And the next step maybe is to investigate the different sources of contamination, mainly in terms of nitrate, to investigate this denitrification process. So yes, I want to thank you. Thank you all for your presentation, for your understanding. My presentation was scheduled later this day, but yes, thanks for giving me this opportunity to present now. Thank you so much.
Thank you so much, Bertil. Thanks for your presentation. Very insightful and very educative. We have some few minutes for questions before we go on a break. I can see Prof. Goni, your hand is up. Please go ahead with your question.
Thank you very much for your presentation. I just want to know, because I didn't see that, how do you have information about the depth of your borehole? Because that may be a good indication as to what you are tapping from. And do it have the type of stratification that we have in Maiduguri, for instance? I can see also you have some sample from the basement aquifer. How are the basement aquifer related to your sedimentary aquifer in the area? Because I am not sure this your classification of the confined system that is composed of paleo water and things like that. I didn't get that very clearly. So can you explain that, please? Thank you. Thanks for the presentation anyway.
Yeah, thanks, Prof. Goni. If I understood well, the question was about the depth of groundwater, and the next one about if the system is confined.
Yes, I said you have depth of the boreholes that you sample, so that we can now relate some of the things you are seeing to also depth, and then the sedimentary system.
Okay. Yes, we have the depth, but not for all the sample. Yes, we have the depth for some point, but I can say that it's very, very difficult in this part of the area, in the field, to obtain the exact depth. Yes, maybe some people in the field, some local people can give you some information, but you are not sure about the depth. Yes, but we have some depth for some point, and yes, I also want to raise that it is, yes, during this the sampling campaign, during the project, we also wanted to have yes, the piezometric information, but it's very, very difficult. The piezometric information on this area, it's always from old study for all project in the area. So yes, it's very, very difficult. And yes, we have some confined, the regional aquifer, it's quaternary aquifer, it's very, very complex. Yes. Yes. And the shallower one, the shallow flow path is very, very unconfined, but you can have some confined system in this deep one, which is more protected from surface pollution. So if I understood, I don't know if I answer your question.
Okay, so
we'll have to go to a break now anyway.
Pete.
Sorry for interrupting.
Yeah, Pete, ask your last question. Pete, can you ask you the last question before the break? And time is up.
All right. Thanks a lot, Chair. Mine is just a follow-up. I think I just want to understand how widespread is the contamination, and also, are you beginning to think of remediation based on the type of aquifers that you have? Thank you.
Yeah, thank you so much for this question. Yes, the main thing I can say about contamination is the problem of sanitation. Yes, there is no sanitation system here. It is very, very difficult. We have agricultural activity, we have breeding, and it is very, very difficult to develop or to maintain an adequate sanitation system. And about the remediation, not yet for the moment in this part, but in the northern, because here we are in the far north, and in the north part, yes, some people begin to think how to remediate by using natural, nature-based solution, yes, but not yet in this part.
Okay, thank you very much, Bertil, for your insightful presentation. Thank you for your questions. And as I think it's time for break. Seifu, any announcement?
Not really from my part. After the break, I will have Prof. Cheikh Gaye giving his keynote address, and then I'll introduce him later when we get back. So, and then be reminded that later in the afternoon, we'll have our closing, and the closing will be done by Dr. Rashid from AMCA, and we hear from him on reflection on the African groundwater agenda post 2025, consolidating what Dr. Khalist has told us before yesterday. And please join us also for that session. And then it will be preceded by presentation by Edward and Behailu on the survey results. I believe it is an exciting result. And then let's see, stay tuned in the afternoon. So 5 minutes break, colleagues, and we'll reassemble in 4 minutes now already, in 4 minutes. Cheers. Yeah, thank you so much, Prof. Cheikh Gaye, for your willingness to deliver this keynote address on using isotopes to uncover hidden groundwater resources in Africa. And Prof. Cheikh Gaye is not someone to be introduced. We all know him. And just in case if some of us do not know Cheikh Gaye, Prof. is a known hydrogeologist from University of Cheikh Anta Diop, Senegal, and he has extensive expertise on groundwater resources and isotope hydrology, and he played a really leading role in advancing application of isotope techniques to uncover the dynamics of Africa's hidden groundwater resources. And he has been key contributor, and then he was also staff member of the International Atomic Energy Agency. And through that, he has led a number of projects and programs on isotope hydrology in Africa that has led to an excellent understanding of the African aquifers from all over, I would say. And then he's also a dedicated mentor, trained many young hydrogeologists in Senegal and beyond. And today he delivers his keynote on isotopes in uncovering hidden groundwater. And Prof. Cheikh, please, it is your time. Thank you so much. Please
okay, thank you, Seifu, for your introduction and your kind words. I must also thank you for first having this initiative to organize this amazing conference. I have been following this event since the first day, with the introduction from Calixte until now, and I realized that a lot has been done since we started to do hydrogeology and isotope in Africa in the late 70. So I must really congratulate you and your team and encourage you to continue. Just one thing was hurting me a little bit. There was not really enough French speaking. I don't know if it is the language barrier or if it is something else. But I think an effort needs to be done also to mobilize the French-speaking hydrogeologists. Having said that, I will just, I must also say that you are just kind to ask me to do this presentation. You yourself, you could have done it. Many of you could have done it, like Seinabu, like Baba Goni, and some I don't know. So I will be request your, how to call it. You will forgive me if what I'm saying is not to date. or if there are some mistakes. You know, I've been retired now since 17 years already. So I'm trying to keep updated, but it's not always easy. So the outline of my presentation is to introduce to recall the fundamentals of isotope hydrology. Then I will talk about isotope techniques for groundwater exploration. And then I will give some applications in identifying hidden groundwater. Very few applications, that's indeed. And then I will discuss some challenges and advances in isotope hydrology. Just to start with the definition, isotopes have the same number of protons, but differ in neutron count within atomic nuclei. So we have similar properties, they exhibit similar properties, chemical behavior, but due to the difference of masses, you can use them as traces. And I have seen many examples already that was presented by your brilliant speakers. Just to recall that you have this isotope fractionation. I'm sorry. If you go through the water cycle, you will see that you can identify each portion of the water cycle using its isotope signal. And this is what we call that using isotope for fingerprinting. And it's really the best tracer for water, the origin of water, and the changes in the hydrological cycle. And this property will be used to trace groundwater. Now, if you talk to isotope techniques for groundwater exploration, you have, as already said, you have stable isotope methods and you have radioactive methods. For isotope stable methods, you use non-decaying isotope to understand groundwater source and process. And for radioisotope methods, you will use radioactive isotope method using the decay to estimate groundwater age and dynamics over time. All this you already know. What is most important is really when you do the sampling and the analysis. Because all the tracing technique, the basis of tracing technique is to sample water to analyze it. And the data you collect and you gather are interpreted having in mind the geology, the hydrodynamics. So it is very important to have a proper sampling to ensure the integrity of groundwater samples for accurate analysis. And I'm sure all of you have already gone through courses dedicated to groundwater sampling and how to sample, how to collect a proper sample, which layer is sampled. And actually, the discussion on the last presentation was touching this problem. What has been sampled? And once the sampling is done, you have to keep in a safe place, in a sure and safe place, the sample, and before sending it to the laboratory. And for the technical analysis, you have for stable isotope, you have mass spectrometry, but now more and more you are using the laser machine. I've seen that now in Africa, in most countries, or at least in a good number of countries, they have a laser, which is very good because it will make it easy to do the isotope work and to better understand groundwater in our countries. And I think the examples that was presented are a good example for that. Yeah. For the interpretation of isotope data to locate groundwater, you have the classical diagram, the so-called water meteoric line. And I am sure that all of you know this diagram, where you can see that groundwater, surface water, you can make the difference between the rain, local moderate rain, global moderate rain, evaporation, water interaction, and so on and so on. So. And I think most of you are now familiar with this, and I don't really need to insist. Now, using also the isotopes, you can constraint models. And I'm not presenting this example, but I just can relate one anecdote. The first time I joined the Atomic Energy Agency in 1999, I had a program in Morocco, and there was a big fight between the people who at that time were doing isotope hydrology at the CNESTEN and the Minister of Water. They were investigating the same aquifer, and the people from the ministry prepared a model. And in this model, there was some instances, and it was not well fitted. On the other hand, people from the isotopes group had results indicating some aspects of the functioning of the Aquifer system, which was not taken in account by the Minister of Water. And they never sit together to discuss that. I had to invite them to Vienna. Really the main responsibles of each institution, they sit with me for a week in Vienna. And when they went back home, maybe less than a week later, the head of the section of hydraulic sent me a message saying that they have now adjusted their model using the isotope data. And I think this played really a great role in the development of isotope hydrology in Morocco and the collaboration with the Minister of Water. Some applications in identifying hidden groundwater. I just go with one local example here in Senegal with a program we had with the Seifu that was managed mainly by Seifu, and using the isotope to identify all the problem in the urban aquifer system in Charoy. All of you know more or less it. And you see in the first diagram on the left-hand side, it is the map distribution of isotopes. And on the lower, you have the delta oxygen, delta hydrogen sketch diagram, which indicates the different waters. And you see that most of the waters are more or less contaminated by evaporated water. That can be water evaporating before infiltration, or even due to sewage water. Because in this area you don't have sanitation, you don't have reticulation to evacuate all the water, used water. Everything is dumped on surface, so it is coming to the aquifer system, and it is visible here. And on the top, we have the distribution with the blue dots indicating the urban groundwater, peri-urban groundwater in 2017 and 2007 and 2017. And you see that depending on the depth, you have a lot of enrichment. I have borrowed also an example from our colleague from Cameroon, which indicates this assessing the edge on flow parts of groundwater. For that, you know that you mostly use lithium and carbon-14, and then you can estimate the time that water is spent in aquifers and its renewal rate. Flow rate directions and also are determined. And here you see that with our colleagues, they indicate using C14 and C13 water from different sources and indicating the aging process and the carbonate rock interaction. Always still with our colleague from Cameroon, indicate here the different water bodies, and in some parts where you have some mixing of different kind of water. The challenge is now in advanced isotope hydrology, mainly in terms of methodology and interpretation. You have the isotope fractionation effects that can alter isotope ratio, complicating accurate interpretation of isotope data in groundwater studies. So sometimes it is not very evident to differentiate. So we have to come back now to the sampling, and which means that you need to, before doing your sampling, to really investigate the geology, have a good knowledge of the boreholes, make every effort to have the diagrams, the logs, and to identify really where water comes, so that if you have some differences, you can be able to interpret. You can have also overlapping signatures. And overall, you need to complement your isotope data with the chemical and the geological information. And it seems that from the exams I have seen until now, really a good effort has been made by all the presenters to really fulfill this. They understand this limitation and also the necessity to make every effort to fulfill the gaps. For Africa now, the problem maybe will be the emerging technologies and innovations. I see that, for instance, the analytical methods, the laser is being adopted, but a good example is here in Senegal. They had a laser machine which was acquired at the eve of the COVID period era. So the vendor could not come to install it. And it took them a lot of time to install it. And after installation, maybe due to the conditions of conservation and everything, the machine is not really functioning accurately. So it is an investment that is not being properly used. So I think every effort needs to build the capacity in terms of having good technicians, good people in the laboratories, and so on and so on and so on. Also, probably to adapt to the new technologies using new tools for sampling, and to make sure that you have a good representative of water sampling. And also the challenge of the artificial intelligence will be here. And definitely to integrate isotopic investigations with field work, and also to broaden the applicability into environmental studies. So mainly in this context of climate change. As it was indicated, isotope hydrology techniques reveal hidden groundwater sources critical for sustainable water use and management. And I think that you have seen a lot of cases globally, but also locally. And I am sure the future of isotope hydrology in Africa is very poor. And it is very unfortunate that the workshop we had in Morocco, that was organized by Neston and the American aid, could not have a follow-up. And I wish really that this program will be, and at what stage or not, be reacted or started again. And Seifu, I think, was a great, big actor of this program. And may also, finally, make sure that your studies have good impact on water management. For that, I think it is necessary to have the water managers educated in isotope hydrology, to have people educated in hydrology sitting in water management positions. And a good example is given, for example, by Calixte, who has been well educated in isotope hydrology and who is making a good job. And I think I've seen also one presentation coming here from one of the water managers. And think this is really the future of isotope hydrology in Africa. Having said that, just to solve some conclusions, donc, the isotope hydrology is really a powerful tool to trace groundwater in terms of origin, age, and dynamics. And the overcoming challenge, we need to adopt ongoing advancements to improve isotope techniques in our countries, and this will enable enhancing sustainable groundwater exploration despite the existing challenges. And finally, I want again to thank you for your attention and your understanding. Thank you, moderator. Back to you.
Yeah. Thank you so much, Prof. Cheikh Gaye, for this enlightening presentation, tapping into your decades of experience and pioneering the isotope hydrology research and isotope hydrology program in Africa. And because of your leadership, I would say, yeah, there has been a number of data that has been obtained on African aquifers, which has helped in understanding the groundwater dynamics, groundwater flow patterns, and then also on recharge on the vertical flux through the unsaturated zone using the tritium profile, chloride profile, and all that. So the power that the isotope hydrology has, as you have rightly said, is very promising. And then also you have highlighted the new innovation around measurement capabilities using laser spectroscopy, which would enable some of us in some African countries to establish isotope hydrology measurement laboratories. And then also you have highlighted about this word of caution. Like any other method, isotope hydrology is a method. It's not a standalone tool. It must be combined, as referring to case in Morocco. It has to be coupled with other methodologies, field work, field data gathering, geological mapping, hydrogeological mapping, pumping tests, remote sensing, etc. So this is like a tool among cocktails of other tools, and then must be combined with. The challenge you have also highlighted is with mainstreaming isotope hydrology into conventional water investigation programs in countries, by departments, by government departments, by documents. That is what we don't see as part of tools for water resources assessment. Maybe that is outstanding, and then that is also what is being supported by the sustained and peaceful use of isotopes, SPDU programs that you mentioned. There was a workshop in Morocco, financed by UK and US government, I think it's not something interrupted. I think it will be continuing, and we may hear from them soon about how to support and continue supporting the isotope hydrology research and laboratories in Africa. I think it has not been stopped. It will continue probably, but we'll hear from them very soon. So having said this, I give the floor for participants for questions. For sure, there will be many, and there are already 2 hands up. First, Sainabu, Sise, there is also the member of organizing committee, and followed by Goni, Prof. Goni. Sainabu.
Okay, thank you, Professor Seifu. First of all, I want to congratulate the team, the organizing committee, for this wonderful work, which is very inclusive. I want to say that include different parts of our continent, just to see the state of our of using isotope tools in groundwater. Thank you also, Professor Seifu, for sharing all information and facilitated our participation. Secondly, I want to thank also my professor, Cheikh Gaye, for this wonderful presentation on isotope application to groundwater tools that have greatly helped us to understand this resource and how it works in different types, in different topics, particularly on my topic in groundwater pollution in urban environment. Cheikh, thank you for initiating us into these techniques and for this wonderful job you are doing in our department at the geological department in Cheikh Anta Diop University. It was only a contribution on this way, but I want also to give my apologies to Professor Seifu for the participation of French-speaking countries on this webinar. I had committed to do it, but finally it was very difficult for me because I have many commitment, and it was really due to my agenda. I apologize for that. I think Seifu next time will be great. Okay, I think it is all I ought to add to the presentation of Cheikh Gaye. And finally, I conclude again with thanks and congratulations to all the team for this wonderful meeting. Thank you, Seifu.
Thanks so much, Sainabu. And then there is another question from Prof. Ibrahim Goni. Please go ahead.
Thank you very much, Seifu. Thank you very much, Cheikh Gaye. It's been quite some time when I hear, and I really appreciate your keynote presentation, and sure there are all the basic things, but bringing us up to the challenges. One thing I'm just trying to think about is I appreciate the fact that you said managers of groundwater resources should be brought into this isotope idea. But then I thought it's to do with the challenges of cost, challenges of sampling, and therefore the isotope tends to be a little bit more spatial tool. And maybe that's why It may not be conventionally day-to-day activities, and therefore bringing in the managers, it's good to educate them to fill in. But what is your take on that? I thought the reason why it's not quite is the limitation of analytical tools, especially, although so now the laser is becoming a little bit more and more available, and but it's still we have challenges of sample analysis of isotopes even now. I don't know what your take on that. And if you think of bringing managers in, which is very good, but the ease of doing that, how do we do that more effectively? If I may ask. Thank you very much once again, and I'm happy to hear your voice.
Thank you so much, Prof, for the question. And Prof. Cheikh, would you want to reply to that?
Yes, Seifu. Thank you, Zainabu, for your intervention. I think she just made a contribution, and I appreciate your taking your responsibility in this, in the lack of a good participation of French speaking. And I think for the next time you will do the needful effort. We appreciate. Regarding Ibrahim Goni, I think the major problem in Africa is the fact that civil servants are very, how to call it, mobile. From my experience, you train many people, but as soon as they are trained, they gain some new experience and they are upgraded. So they change position, and it is becoming really a kind of a sort of always, and sometimes they are given a position which has nothing to do with isotope hydrology or with water management. And I think the new program with the Atomic Energy Agency having this, how to call it, doctorate sandwich program to train some doctors. We have to fight for that. These people who are trained, at least some of them came from the Ministry of Waters. Usually they have engineers, and these engineers can be given a chance to have a doctorate based on isotope hydrology, so that when they come, even if they move in an executive position, they know the value of isotope, and once you like it, you will always like it. You see what I'm thinking. Thank you.
Okay, thanks so much, Prof, for your replies. And then, yeah, any other questions, colleague? Maybe one or two additional questions. There is one question in the chat box asking about utility of isotopes in studying springs, cold springs in mountain setting, and then deep groundwaters ending up as springs. Is there any such experience, Prof?
Oh, yes, I can, even for this interest of using in springs, actually, the problem in Morocco was that they were sampling springs also. And it was not easy to define where the water is coming, this spring water was coming. In some parts, it was said that they were coming from a certain aquifer system, but there was some, how to call it, impervious layers that prevent this water to come where you have the spring. And also in Uganda, we have the Kisoro example with Calixte. We investigated, they had this problem of the origin of the source springs and using isotope. And actually it was a program that was supported by the Austrian government in Uganda. And it was the people from the ministry in Austria who came to the agency and asked us to see if we can help them solve this problem. And we did this sampling, and it was one of the big successes in the early 2000 in Africa.
Yeah, thank you so much, Prof. As you have rightly said, using isotopes for studying origin of springs, determining altitude of recharge to springs, cold or thermal springs has been one of the conventional classical application of isotope hydrology in 1970s across the Andes Mountains in East African Rift Valley to trace at what altitude even recharge has happened in Kenya, in Ethiopia, in Mount Cameroon, and then even in more regional, very long distance groundwater travels. Yeah, it was one of the conventional areas where it has been applied. Yeah, okay, thank you so much. I think for the interest of time, we move to the next presentation. I'll hand over back to Cynthia or Anthony or Piet to chair the next session.
All right. So I think, Ayoade, you can start your presentation.
Well,
if you're
thank you
ready.
so much. Yeah, I'm ready. Thank you so much. Distinguished organizer, the colleagues, this is very important to me. So to collaborate, to network, and then to share what we have been doing in Nigeria. So the topic is urban hydrological risk in changing environment. This is a community perception and then potential health risk based on the petroleum contamination around the groundwater sources. Next, please. So the next slide, that's myself and colleagues, and then it's a part of a PhD research and then a group to look at these important areas from part of environmental health. So I will go through the presentation, introduction, issues, objective, methodology, then result and discussion, and then we conclude. So I will not bother you with much. You know, groundwater is very special. It's indispensable. It's just the major water supply for urban people in Abeokuta, and then from boreholes and the well. That's and then it's for various uses, for drinking, for household, for washing. Okay, and then as you know, the environment is basement complex, Precambrian rocks, and then calcite. Then along the time, it's been weathered and fractured, where they source their water from through drilling and then shallow wells and then deep well. So the issue is this: the urban area, always experience urbanization, road construction, and then we have these activities from people, and then unfortunately we have about planning, regulations and issues, and then we are focusing on resident knowledge, attitude and perception, so that how does they face the risk and vulnerability, issues of public health issues and concern. A lot of people have discussed about technicalities, about modeling, but we are really don't bother about the people perception. So these are the focus of the study. You know, we have the risk, yes. Then the quality has issue because they are closer to filling stations, or so that from the vapor, from seepage, from leakage, they can end up in this groundwater. Then what are the resident perception, attitude, knowledge? We now focus on the major road, which is Adata, Obantoko, Oshele, Ibadan Highway, a very busy road. So we have a lot of filling stations along this road, and then we have heavily density popular area. Now we are now putting these concepts, hardware and software, like a computer system, hardware and software component. A lot of people have been talking about hardware, bore drilling, technical issues, but our people, the users, they don't understand these grammars, these technical issues. That's software. We're looking at software to manage the groundwater. the security of the groundwater, safety of the groundwater. Yes, we have the good aquifer, we have a good infrastructure facilities, but the users, what's their concept? What's their attitude, knowledge about this water quality, water issue? So you can see these issues now. People, they source their water from seepage, they don't care about the source. These are the issues we're looking at because of weak governance, and these are the issues we're looking at. You can see the sources here now. These are shallow well, open well, so unsanitary. Look at this pump here that can easily allow seepage, leakage to the groundwater system. So these are the issues we are looking at. They can also see on my left side, it's a gutter system with oil spillage from nearby filling stations right on the streets. So, and you can also see on the side, people, they know when there's any water scarcity, they look for any ways to get water from. This picture here is because of road constructions, they expose the pumps, they expose the water corporation pipes. Then this is a big issue for the groundwater. Then we look at, okay, what is study? For what I'm looking at, there are little or not limited of this assessment, and then the source, and then the knowledge of people is, so there's little in this study area. So with these three items, 1, 2, 3, we are looking at how you can integrate that to model at risk, looking at the component I was talking about, software component, the people, knowledge, attitude, and perception. Yes, the people can give them a good borehole, well secured, but what is their attitude? What's the knowledge about groundwater contamination, groundwater safety and security? That is what I'm looking at right now. So therefore, we look at these three objectives. So we assess and integrated these three objectives, A, B, C. Okay, there are the analysis of the petrol station, the issue of alternative, just a basic one. Then number C, the inspection of these sources. And then you look at the household. For the A, you look at GPS, just the basic latitude and longitude. Look at the using of a meter to get the pH, EC, TDS at the spot, at these water sources for the people. And then we use the form to spare the inspection of the sanitary condition of this borehole and well. And then we look at 3 households in those areas. Okay. Then we use this method, statistical method, to just analyze the descriptive and inferential. Okay. Now these are results. Though it's ongoing, this latitude and longitude, you can use it for gradient, water movement. But right now, we are looking at just the people, attitude, knowledge, and that can be now put out into our model. You can see that the station between these years, that means it's likely tanks as issue that will leak this content or the vapor from this station. You can get into the open well. So that's why we're looking at all this data. Then from results, the pH, the temperature, the EC is there on average anyway, but we have an issue with color at 3 points. The color is brownish, pale at 3 points of our sampling. Though the odor was not perceived, but we can go further, but it's just a tertiary evaluation using our eyes and color, our nose to test all these things. Just a rapid testing. Now, this is unfortunately the risk to the borehole. Out of territorial borehole, the first one, 33, it has high risk, that is scored there. And the second one, this category B, 267 sources, has very high risk. This is possible because of what? The condition, the location of these sources. Then we use a chi-square test, just association, just to determine how does these people think about the groups. Those are educated, the age, then all of these have similar trend. They have similar responses towards water safety, trust in quality, the issue of the earth. They have similar the responses, okay? That's what this one chi-square test gives us. Then we can go further, okay? It's okay. You can see that the age, the gender, education level, associated. They have the similar, that's it, similar way, thinking about this groundwater safety, and then the trust in the groundwater quality. Though the water quality may be having issue, but they say, oh, they believe in that, oh, it is okay. These are issues that we're looking at. Then, we have using the regression analysis, but the predictor of this earth condition has to do with how closer the household, how closer the borehole are to the filling station, and then the risk, because most of these wells are not properly constructed, are not properly taken care of, they pose risk to the consumer. And then most of them, the safety, water safety is very low. They believe that the water is safe for them, and then they have issue of trust in the water quality. They don't care about the quality. Whatever they see, they consume, drinking, for washing, and so on and so forth. Then you can see the picture here. This is one of the road. We have this drainage system that people, they go there to source their water from. They believe it's hidden resources. They believe it's okay for them. Whereas these are issues because they have no knowledge, poor perception, attitude, and then we have poor regulation. It can be an issue that we're looking at here. Then in conclusion, the community have a low awareness, low limited knowledge of contamination, low perception. They cannot link the diseases they're experiencing with the water they consume. And also we can see that most of these elements were more observed with people closer, or they use water from the filling station. And again, unfortunately, they see water as a social good, that government should take care of their water for them, which is not right. Water should be seen as economic good. You take care of your water, you make sure it is okay, and then meanwhile, there's a misresponses that people, they don't want to, some are willing to get involved, okay, like the CDA, those that are in charge of the community, they're ready to get involved, but those, the others, the followers, the household people, they lack interest, so they don't care, okay, so far it's just any water to consume. So we are now saying, okay, we need to do proper orientation, orientation that water is not a social good. People have to get involved, okay, and then we need public health interventions. Then also, there should be adequate, continuous monitoring that will involve the resident, and then must enforce the petroleum infrastructure siting regulation, and so on. So all this is just an ongoing. This is just a part of a research, so that all this information, I want to put those KAP into the model of the earth risk. This is what I've been doing so far. So thank you for listening, and we appreciate your contribution, your direction, your comment, and observation. Thank you so much. Thank you.
Thank you, Ayoade, for the presentation. Yes, please, the floor is open for questions. Any comments?
Yes, just a remark. I think yeah, this is a very good observation about people's perception and knowledge, which is part of the social hydrogeology. And then in analyzing the data of the sort when collected from the field, I think there are some frameworks against which such data could be analyzed. Call it social hydrogeology or self-supply, or call it whatever. Yeah. So I think maybe this kind of data, if analyzed against a certain social framework or conceptual framework, it would be very analytical and useful and scalable across other regions. So very good observation. Maybe expand this on to a scalable level would be a very useful next exercise. Thank you.
Thank you so much.
All right. So thank you, Ayoade. We'll move to our next presenter. Vinel, are you ready? Vinel?
Yes, please, I am. Yes, please, I am.
Okay. All right, so please kindly share your presentation.
Okay, thank you very much. And I am very grateful to be part of this first Pan-African Hydrogeology Congress. I am Vinel Gbewezoun from Benin Republic. Receive greetings from Benin. And I will be presenting on new insights from the use of water isotopes in the Beninese part of the Iullemeden Aquifer System, securing sustainable water resource for Benin. So I am a PhD candidate from Benin Republic. I am doing my research at Laboratoire Hydrologie Appliquée, and I am doing the research in the framework of the International Atomic Energy Agency PhD service program under the supervision of Professor Mama from Benin and Professor Gaye from Ghana. So this presentation is part of the work and it has been already published. So I will just give you some highlights, and at the end you will have the links toward the presentation, the paper for further readings. So the main motivation to this research is to have a new understanding on how groundwater and surface water are interacting in the basin, because the Benin part of the Iullemeden Aquifer System, when we look at the documentation, this part is mainly left out. So that with the gain interest from regional projects and national projects, some understanding are now coming. So the main motivation, this is the outlet and follow after the motivation. I'll talk about the methodology, the result, and some concluding remarks. So the main motivation of this presentation, work that has been done, is to use water isotopes such as deuterium, oxygen-18, and tritium to quantify the water flows exchange between the River Niger and the Iullemeden Aquifer System, locally called Kandi Basin in Benin. So as you can see, I don't know if you are seeing my. So as you can see, the study area is located in northeast Benin, where Benin share border with Nigeria and Niger, and it is also part of the Niger River Basin. It covers around 9,000 square kilometers and is basically composed of sandstone formation, and it is characterized by a semi-arid climate. So the methodology that have been used in order to tackle the issue, 36 samples have been collected in the fields, of which 16 from surface water and 20 from groundwater. Those samples have been analyzed for deuterium and oxygen-18 and tritium for have been analyzed in Tunisia, but it is also important to highlight that for oxygen-18 and deuterium, some duplicate analysis have been done at the laboratory Hydrological Appliquée in Benin, the new acquired laser in the framework of the IEA project. So the rainwater sample have been collected from May to September for tritium analysis that have been done at the laboratory in Hungary, but for the stable isotope analysis, it has been done by the IEA. So complementary results available at the GRIP portal have been used to have more consistent precipitation data. And in order to assess the contribution of either groundwater or surface water, we use a Bayesian mixing model available in our software, and that we have complemented with principal component analysis. So let's continue with the results. So as you can see, using the bivariate plot of deuterium versus of the stable isotope of water, you can see that we have been able to identify 4 types of water, starting from the relatively old groundwater that contain the artesian borehole identified in the study area in the Niger Valley. And here we have the missing of groundwater, shallow groundwater and deep groundwater. As you can see, we have borehole and hand-dug well water missing together here. And from the group 3, we have missing of relatively shallow groundwater and surface water. And for this one, the group 4, we have the surface water and characterized by this evaporation line. So, in order to further confirm the findings, we have used the content of all the content of either deuterium, oxygen 18, and tritium. But deuterium and oxygen 18 have been combined, and deuterium SS to design this plot that allow us to identify 4 main groups of water. As you can see here, we have this one mainly composed of groundwater. Here we have the missing of, you can see here we have 2 types, but the class is B, but here we have the class B, G corresponding to this groundwater. And here also we also have the similar process here. Am I still audible? Hello?
Yes, yes.
Yes,
Okay,
you
okay.
are.
Okay, so if you remember here, those groups identified have been also highlighted here by this plot. So I will continue. Okay. So after we carry out the missing analysis, we have the group previously identified over there. This is the synthesis of their percentage. Like I was saying here, this group. So the groundwater presented here, they are the one here. So you see, their composition of groundwater is very high. That and as we previously noticed that it was the missing of surface water was not really important, so it's also captured here. And as you can see here, this sample, they are the one here. So even though they are surface water, that their content of groundwater is very high. So it's the same applying to classes, and you can see, take for example this one, the class D is relatively composed of surface water, as it should be based on the result, and then those groundwater that are showing relatively high content percentage of surface water, they are the one here. So further continue to carry out a Pearson correlation analysis, and also those analysis and the PC analysis, those analyses also confirm what we have previously identified. So this is a synthesis of a view of what we have been talking about, but this time we are having the spatial overview. So as you can see in the Candy Basin, based on my research work in master in 2017, you can see that the water flow is generally from south to north. with groundwater the basin in Suta River and Niger River. That one was highlighted by piezometric analysis, groundwater flow. And based on what we have, the work that we have also done now, as you can see here, the CS, the CG, you can see they are located in the discharge area of the groundwater resources. And where we identified the DG and the DS, you can see the DS, they are here, and the DG is here, they are here. So that is showing us that combining the isotope analysis, we can further confirm previously knowledge carried out based on a traditional analysis. So, and it is important to highlight that the artesian borehole identified here have never been sampled for tritium analysis. So when we carry out the analysis, it did confirm that it is a old water, a water reproduced very long time ago, and we observe in the field that that water is just flowing without a proper monitoring. So based on that, there is a risk of groundwater mining in that area, because over here, the previous artisan borehole have been providing water, but later it dried up. So measures should be taken to avoid the drying up of this water as well. So, and the Soso waterfall also have been sampled, and it's also a new input from this work. So basically, what we have found is mixing of deep groundwater with shallow groundwater, the groundwater discharging in the Suta River, as identified previously by the groundwater flow map, and the replenishment of shallow groundwater by Adegbite and Niger River, Latin here. And like I already explained, groundwater mining occurring, risk of groundwater mining occurring in the Niger River Valley. So, as concluding remarks, I can say that combining the knowledge we have on water isotopes, such as tritium, deuterium, and oxygen, have been able to quantify groundwater, surface water interaction in the Kebede Basin, and a complex hydrodynamic relationship between the Aquifer system study and the rivers have been identified. And for the deciders, the policy makers, in the Kebede Basin, groundwater and surface water can no longer be considered as different type of water bodies. Their management must be done considering that they are a unique water body system with different components. This will ensure sustainable water resource in the study area for the well-being of the local community. So, as I stated previously, the work can be accessed using this link and published in 2024. But before to hand over to the chair lady, I would like to thank the Beninese authority for allowing me to participate in this project, and I will also thank the Ghanaian authorities for hosting me at the School of Analysis, and that allowed me to interact with specialists from Ghana Atomic Energy Commission. And I also thank all the stakeholders, either from Benin, Ghana, and IEA. And I thank the IEA for funding this research. So thank you very much for your attention, and I'm available to connect and to collaborate. I welcome your question, contribution. Thank you very much.
Thank you, Vinel, for the presentation. Participants and panel, please, the floor is open for comments and questions. Any contributions?
Yes, there's.
Okay, go ahead.
Oh, okay. Can I go ahead?
Yes, yes, go ahead.
Yes. Yeah. No. Thank you for the good presentation. I think one thing I appreciate about your presentation is the use of multi-model utilization, and that actually gives you confidence in the results that you have, and that enabled you to identify those types of waters, which is really important. What probably is not coming out clear, which you may want to clarify, is the type of aquifer that you are dealing with, and to what extent is closer or far away from the river itself. So you could probably explain a bit about the aquifer characteristics in your area. But in terms of the results, I think you are on the right track and it's really appreciated. Thank you so much.
Okay. Thank you very much. Back. Yeah, in the study area. Oh, sorry. Can I proceed to answer the question?
Yes, proceed.
Thank you. So regarding knowledge about the study area, I have done previously my master on this aquifer system, and one key findings was that the system is not like we can consider that it is a big aquifer composing of different facets, changing depending on either you are the salt of the north. That is why you notice that the artesian borehole identifier is basically located in the depression area. So because of the importance of the layers over there and the pressure under which it is in the valley. So for now, that is what I can say, but we can still keep in touch for further clarification or contribution. Thank you. Okay.
If there are no further questions, we'd like to thank you, Vinel, for the presentation.
All right, thank you. And it was also nice to meet you here again.
All right. So we'll take our next presentation from the organizing committee. Behailu, are you ready?
Yes,
Okay,
yes, Cynthia, thank you. Edward will start, yeah.
Okay. So we are going to take the results from our survey. Bam, if you are ready, you can take over.
Yeah, thank you, Cynthia. Can you see my screen?
Yes, we can see it.
Yeah, so thank you everyone for the patience all up to this point. I think we have come to a very important juncture, basically to give account of our capacity as hydrogeologists working across Africa. And so at the beginning, we took this survey. Most of you participated. We are still waiting for some of your results, your submissions. So basically, that's what I would say. So as Cynthia mentioned earlier, this will be presented on behalf of the team. And just give me 1 minute here. I think So on the screen, you have my team members, people that I've been working with, led by Professor Seifu, Olivia, Lydia, Cynthia, Nawal, Mahal, Faye, Odi, Anthony, Piet, And yeah, I mentioned Seifu earlier on. So basically, this has been a team working to get this done. Myself, Edward, and Behailu will give you the presentation. The first part basically will be to give you an overview of the capacity as we gathered from the abstracts that were submitted, and then also on from the survey that we had. So from the beginning, as we mentioned, our objective is to collect data to identify some of our training needs, knowledge gaps, and then collaboration opportunities. The survey basically came in mixed method forms, which means that we have some open-ended questions, closed questions, metrics, and then also multiple choices. We confine this survey to people who have obtained their first degree from recognized universities in Africa, and also people who reside and practice hydrogeology in Africa. So as I mentioned, I'll give you an overview of the abstracts that we collected and the distribution of the various capacity dimensions. That's what I'll talk about, and then Behailu will take over from there to speak about the survey that we took at the Congress. So basically on the abstract distribution, these are the countries that we got abstracts from all across the continents, the ones in green. And the years of experience of people who have submitted the abstracts range from almost 0 to over 30 years in the practice of hydrogeology. And you can see that close to 80% of the people that submitted the abstract had less than 10 years of experience in the field. We look at the qualification and the years that they graduated. The distribution basically shows that majority of the people who submitted abstract had at least a master's degree, followed by a PhD, and then BSc. Other qualifications were also indicated. We looked at the years that these people graduated. Majority of the people who submitted abstract graduated after 2010. So you can see clearly that after 2010, we had a very sharp increase. So basically, less than 20% of the people graduated before 2010, I should say. We looked at the places, the countries where they obtained their degrees from. So this is basically the distribution of the people, again, who submitted the abstract, the countries where they had their degrees, whether BSc, Masters, or PhD. The gender distribution, basically, we have about 10 out of probably 70 abstracts that were selected. So, Behailu, I think I will hand over to you.
Thank you, Edward. So this is still a work in progress. We haven't completed the survey. It's just a quick review of what have been collected so far. So it's probably not neat as you expect. So if you see something wrong, please bear with me. I will try to present it as slow as possible to encourage discussion later on. That is the purpose of the presentation. So I'm not going to just skip on, but try to be a little slower than usual. So there are 9 categories of the questions. Under each category, we have about 5 questions. So for the sake of clarity, I will try to present it category by category. So the first category is about more of demographic and professional background, general information. So we collected a total of 76 respondents. And these 76 respondents represent 33 countries. So if you try to look that in terms of age distribution, you see that let's say the majority will fall on more than 32% will fall on 36 to 45 years old. And I mean, looking at the range of the age variation, you see there are so few. There are very early career professionals like the age within the range of 18 to 25 years. And we have also seniors with the age above 60 years, right? So that is really interesting. Gender has always been disappointing, so something to still work on. So obviously it does not represent the number of hydrogeologists in Africa, but this is only on the survey. Based on the survey, only 14, a little more than 14% were female participants, so the majority is male. So in terms of countries of residence, where they reside on currently, so you see that most of them are from East Africa. Of course, it's really promising that we have a range of participants all the way from the north to the south. Number varies also across west to east. That's also one good thing. In terms of organization, the affiliation of the respondents, most of them, as you would expect, is from the academia, from the university. Of course, there are also measurable number of respondents from government agencies, and it's really interesting to see participants or respondents from private sector too. So this is the general information regarding the demography and professional background of respondents. Okay, we can move to the next slide. So under category 2 is more on education and training. You see that there is a fair comparison of early career professionals with less than or up to 5 years of experience, about 30%, and the same proportion of respondents are seniors, like experience of more than 15 years. Okay, so that is a very proportional or fair capturing of information from early career professionals to some prominent figures, seniors. That is in terms of years of experience in particularly hydrogeology. In terms of academic qualification, most of them are MSc graduates, about 36 of the 76 respondents, and there are also a measurable number of PhD holders. Okay, it aligns with also the years of experience, right? So, but we have BSc, which is not insignificant, I would say, also diploma. So it's a very good, I mean, representation of all range of academic qualification. And formal training areas reported. Probably, if you see the number of abstracts submitted, I think that this aligns with that because most of them are from chemical analysis, but there are isotope hydrology, numerical modeling, contaminant hydrogeology, and etc. So these are formal trainings that people get, but also there are respondents who don't have this formal training, but they are interested to have the future. So that will also a kind of, in a way, inform which areas of capacity building should we think of. And preferred training formats, there are a range of training formats, as you know. So most of the respondents with a hybrid combination of online and in person. Probably this would have been a different response before the COVID hits, right, the pandemic. But now it has almost become a common exercise to have these online meetings, online trainings, and etc. So I think now we're used to the fact that we cannot get rid of these online formats for every types of engagements, and the respondents, most of them, they prefer a hybrid combination of online and in person, of course. A significant number of respondents also prefer in-person workshops, and also a measurable number of respondents prefer to have just online live sessions, and also self-paced online courses. Okay, so you see that if you count all categories where people prefer online, this is huge, I would say. Whether it is in combined form, whether it is online live or self-paced, you see that we have become more comfortable in online types of engagements. So the language of training preference are mostly English, of course, French, Swahili, Arabic, all are selected depending on from where the respondents are from, but the dominant number is English. So category 3 is capacity gaps and challenges. So the first question was like, what are the challenge in hydrogeology work? This is we respond ranking the highest to the lowest. Okay, so the first one was lack of access to funding, which is the significant number of respondents. Of course, not only that, limited access to field and lab equipment are also mentioned. Of course, we didn't scrutinize what other category is, all right? It's only those which are labeled, but significant number also responded other, but the others are not part of the analysis now, that we will see which are the other challenges mentioned in the future. Of course, inadequate training opportunities and poor collaboration or networking is also a significant number, right? It's not something that we need to ignore. So this is in terms of challenge in hydrogeology works. If we go down, barriers to monitoring junior professionals, still funding limitation. Probably it needs explanation what that supposed to mean, but funding limitation, significant number of respondents. The barrier mentoring junior professionals was mentioned. Of course, lack of this appropriate structure to mentor. It's also mentioned. Time and lack of interest is also even though smaller number, there are also respondents mentioning that as a barrier, but the prominent ones are funding limitations and lack of this proper structure of mentorship. If we go to the right top corner, which is institutional support, lacking financial support, finance is mentioned almost in all barriers. If you see, finance is the first one mentioned as a barrier, but technical support and policy and government support is also the other measurable respondents. So, barriers to participation in regional or international events, finance, big number, but surprisingly, visa or travel issue is also mentioned as a barrier. Of course, awareness, so information, networking, collaboration would be the solution for this, but lack of awareness is also one of the barriers mentioned by respondents. So the last in this category will be equipment lacking but needed. Is the first one is isotope analysis equipment. So it shows also the interest, which is a very good thing. Geophysical instrument is the other proportional number of respondents together with this isotope analysis equipment, and water quality analysis kits, pumping tests, and well logging tools. These are almost up to remote sensing and GIS tools. These are almost a significant number of respondents. In the range, it shows you the range of equipment or tools lacking but needed across the countries. So the next category will be knowledge and skill and research. The main barrier with respect to research productivity funding, obviously, is mentioned. The other is access to data. This is very interesting. So in most of the research from Africa, you see that at the end of the slide, this is one of the commonly mentioned limitation of data quality, which is access to data. So this is also reflected in the respondents. Preferred training topics down at the bottom. Managed aquifer recharge. So using publications, if you look publications in Africa, I think the highest in Africa is South Africa, if I'm not mistaken, but there are only limited practices, managed aquifer recharge practices in Africa. So now it has become more a hit in African countries. So the preferred training topic is managed aquifer recharge, but also groundwater recharge estimation in hydrochemical processes also. Even aquifer vulnerability assessment, there are a measurable number of respondents also. These topics of training. The tools, the top right corner, the tool, and platforms are regularly used. Mode flow and similar models is one, but you can see that, I mean, more than 60, I think 65 respondents, QGIS and ArcGIS. So it has many implications if you dig into this. So significant number of respondents, the tools, platforms regularly used are QGIS and ArcGIS. Of course, Python is measurable respondents, and remote sensing platforms and ModFlow and similar tools are also mentioned. Hydrogeological methods, confidence in use, in which of the hydrogeological methods that we have confidence to use is still there are significant number which fall in other, which we don't know now. We have to scrutinize that in detail. But from the categories which we know, geophysics for groundwater and hydrochemical analysis is a significant number. And the frequency of contribution to publication is also like most of the respondents fall occasionally, right? once or twice in a year, but it's not significant that researchers, at least the respondents, fall in irregular. There are some number of respondents who say they regularly contribute to publication, but the significant numbers fall in occasional, like once in a or twice in a year. So the next category would be networking collaboration. So honestly, I was expecting the reverse when it comes to membership in professional associations, but it's really promising to see most of the respondents actually participate in are members of professional associations. Significant number, of course. There are major numbers who are interested but not member of professional association. Probably something Olivia and Prof will take, and at least awareness is one of the things. Then continuously providing information, at least for students residing in Africa. Olivia was mentioning it's free to register, but probably because of lack of that information, there are still respondents who are not. They are interested but need members of professional association. And the cross-border regional engagement, this is also another thing which really amazed me. There are a significant number of respondents who actually engage in regional issues. Of course, measurable numbers, they don't. The other is the network and knowledge exchange platform used. Unfortunately, significant number of respondents, they are in other category that we need to dig into. But from those we know which particular network or knowledge exchange platform, conference and workshop takes the first, and ResearchGate and LinkedIn platforms take the second. And frequency of collaboration, occasionally, it takes the highest number of respondents, and frequently a measurable number, and rarely. So it's good to see that never is the smallest number when it comes to collaboration. The other is willingness to support capacity building. Happy to see most of them, almost all, respond yes. And to which category? You can see that mentoring young professionals about 35 is the highest rank, and it's good to see that interest to mentor young professionals, educated professionals. Of course, sharing data and research resources and organizing or delivering training is also measurable number, which is promising to see. So moving to category 6, which is regional priorities and future directions. So most pressing hydrogeological challenge. It's really sad because we did a quick review. So we didn't have enough time to bring all the information, especially which fall in other categories. I would like to bring that, but unfortunately we didn't make it. But climate change impact and contamination and pollution, weak governance, and groundwater depletion are significant number of respondents pick this as most pressing hydrogeological challenge. The primary region of work, unfortunately, there are other categories. I don't know which would that be, because we try to put in the options almost all categories, but there are other which are not specified here, but based on what we know, most of them are from West Africa. And aquifer systems, you see that significant numbers. So these are aquifer systems that respondents mostly work on. So this is fractured crystalline rock, is the most, and alluvial, and also sedimentary basins are also mentioned as aquifer systems respondent work mostly. And the other emerging research topics, it's good to see that AI and machine learning in hydrogeology, significant number 47. This is one of the emerging research topics in Africa. The other is water security and resilience. And of course, the other also like MAR, groundwater, lithium extraction, and isotope applications are also significant nearby. So moving to category 7, which is enabling environment and institutional support. So the national groundwater policy or guideline is the question. So you see that most of the respondents said yes, and there are also significant numbers said no. So it's interesting to see in terms of country how this national groundwater policy or guideline plays. So if you see, also you can also how interesting it is based on knowledge, personal knowledge and experience or exposure, that in Ethiopia, let's say, a certain number of people say groundwater, national groundwater or policy, no, right? So if there is national groundwater policy and guideline, is the question, right? So they say no, and some of them are saying yes, right? There is the same, right? The number is so comparable, like 7 and 8. So it depends on the knowledge and experience and exposure people have towards this particular question. And this is something that we need to be highly careful when we do the analysis, right? It's not only in look at like Kenya, all right. Of course, there are, like say, if South Africa, it's also as though the number is disproportionate. Like 4 of them says yes, and the only one says no. But in most of the countries, there are people responding for the same question differently, right? So that is something that we need to be careful when you do the analysis. So if we go to the next one, under the same category, which is integration of hydrogeology into national water governance, right? So you see that significant number said responded like it's weakly integrated, and a measurable number say it's moderately integrated, but there are a smaller number comparatively say it's strongly integrated. So look at the country-wise, right? So you see still in Ethiopia or Kenya, you see that different people respond differently, right? So based on their experience, knowledge, and exposure. Okay, so that really is something which is interesting. Then we have to dig into that, right? We cannot simply say black and white, and there are these gray areas where we need to dig in and try to have a clearer picture. So if we move to the next one, institutional investment in hydrogeological research, right? So the range is from not at all, there is no any institutional investment in hydrogeological research, and yes, significantly, all right? This is the range. So somewhat is the one which is taking the higher number. Significant respondents say somehow institutions invest in hydrogeological research, but also significant numbers say not really, and comparable numbers said yes, significantly. So if you still see it from country perspective, you see that variation, even though, so of course, people come from different institutions, right? From universities, private companies, government institutions, and etc. We saw the range of affiliations of respondents. So based on their experience, where they are coming from, this response is also different, because some in some institution can be better than the other, obviously. So if we move to the next slide, primary source of groundwater related data, which is very interesting. So in the same category, you see that sadly, there are significant numbers they saying are there. So we need to look into that. But you see that peer-to-peer exchange with colleagues or institutions is significant number. This is, I remember Prof was doing one similar type of survey, I don't know, a year or a couple of years ago, how this peer-to-peer data exchange is very important, especially in Africa, where there are no this structured, institutionalized data archiving method. So you see that that is really reflected also in this survey. Of course, there are significant numbers of respondents saying that they get data directly from the field or from international or regional data platforms. So remember that the presentation, the opening remark by Dr. Palis, and there are these initiatives, regional initiatives of data archiving, which would probably be also another good data sources in the future. So looking at this also, if you try to look at from the people coming from the same country, but they respond differently, right? So one thing that I noticed, I don't know if you have noticed already, is one thing I noticed is the responses from Kenya and Ethiopia are really closer to similar or the same. Not to be safe, I wouldn't say identical, but very close in most of the categories, by the way. So if you see the responses of respondents coming from Kenya and Ethiopia, I don't know, it's because of proximity or I don't know what, something to look into, but the responses are pretty much closer. So you see that in Ethiopia, of course, there are other categories, but people are saying that they get data from centralized national database. I don't know of if there is that structured, but probably from the institution they are coming from. But also there are people saying that they get data from these regional or international data sets, okay? So this variation of people, individual experience, knowledge, and exposure is something that is it's captured, I would say, almost in all categories. So moving to the next category, it's if affiliated. This is only for those coming from academia, universities. So modes of module delivery, right? It's really a surprise that there is still this traditional method, chalk and blackboard, significant number. Of course, there are most respondents also pick on other, which we don't know, but significant number that say that there is this traditional method, chalk and blackboard type of teaching. Of course, video conferencing, online learning platforms are also coming in picture. Of course, PowerPoint presentation with projectors is still a common exercise. Of course, is measurable that the field-based practical sessions, not a small number, there are field-based practical sessions. If we look at that from country perspective in the right, so you see also that variation. So in Kenya, you have online learning platforms, and there are also other types, video conferencing. You see the range. So there are practices in these countries, but the practice is not uniform everywhere. There are places where you have more advanced ways of teaching, but there are still places where still we use traditional method of teaching. Okay, that is what it's showing in the right. So if we move to the same category, when was the curriculum last revised? Most people, they don't know when exactly. Okay, so this is something also to look into. Why? Of course, significant number of respondents say 4 to 6 years ago. And if we ask them, this is what happened practically, but if we ask them to the right, how frequent curriculum are being revised, so significant number, they don't know, more than 43%, right? They don't know. But the range, the others show the range, right? So the minimum being, I think, every 2 to 3 years, right? But significant number, if they know, which is more about 24%, is every 4 to 5 years. Yeah, this is how often curriculum is being revised based on the respondents. Okay. If we move, the last category is employment trends. So the one to the left here, institutions or companies were established. You see that most of the respondents actually they come from institutions which are relatively recently established institutions, right? Relatively recently established institutions. And the type of institutions you can see to the right is mostly public government agencies and academic or research institutions, of course also private company or consultancy. There are others, but these are the major ones based on the respondents. Okay. The other is employer preference for hydrogeologist training background. So if the institutions prefer employers of hydrogeology background, okay, so the no clear preference is, I think, the significant number, and a strong preference for, so this is, I'm sorry, I have to clarify. So this is as to if institutions prefer employers of course, hydrogeology training, whether from the local market or from international market, okay? So significant numbers say there is no clear preference. Both are valued, means both local experts and international experts are valued equally. So there is no any preference. But some preference for international trained is also significant number, and strong preference for international trained is also a significant number. Preference for local trained is also there, even though smaller. I don't know. Of course, there are some number of respondents I don't know. So if you see, compare that, where actually is there that preference, whether local or international experts preference, you can see that in Ethiopia, no clear preference. It's a significant number. Of course, there are also a number of respondents saying that there is a preference for locally trained professionals, but significant numbers says no clear preference. So in Kenya, you see also the pattern. Of course, in Kenya, it also indicates that there is a strong preference for internationally trained, right? The number being 3. So you see that this category, the one on the left, tells you whether there is or not, but the other is to, if you want to dig into country level comparison, and this gives us a very good picture. So the next would be, what would be the impact of this decision, right? So what would be the impact of this decision? So significant number say there is no significant impact observed, but also a significant number of respondents say there is limited access to senior or specialized role. So if you prefer inclined to local experts, then the impact would be you may have this limitation to get more senior, more specialized roles. Okay, so that is how the impact would be displayed, and it's also something that we can further look into in terms of country level comparison. I'm not sure if there is any more slide left, Edward. Yeah. Thank you for your attention.
Thank you so much, Behailu. Who is leading this? Lydia, maybe if you could lead us a discussion, open discussion on the survey. Lydia, are you around? Or Anthony?
Yes, I'm around.
Yes, please.
Okay. Yeah, thank you so much, Behailu and Edward, for compiling those survey results. Very interesting, the level of training, preference of the market, and also the level of training that people have, those who came to this particular Congress. And I think it's very interesting, and many of the attendees who are here at the beginning have actually stayed, and I'm looking forward to a lot of questions or discussions about this. So let's open it up for people who would like to ask any questions or also for clarification. So there's a hand up by Ayoade.
Oh, thank you for representing me. This is a beautiful one. So I just want to know if it will be a continuous exercise so that you can get prepared and put more people in. So that's just my question. To appreciate and then to ask if there's more of these things to be coming so that you can get others, my colleagues, my students, so that they can get involved too. That's my question. Thank you so much.
Okay, Prof. Seifu, I think I want to pass that to you.
Yes, point well taken. Yes.
Okay. Yeah, I think, we're planning to have it regularly, but of course we'll be able to inform you in advance. Yes, then there is a question from Professor Goni. Please go ahead.
Thank you very much. Just to reflecting on the survey, which is very, very good and showing some trends. What I can say there is just to pick up those activities or things that can easily be implemented by the organizers, for instance, like attending of conferences, how to make publicity, make it known to people in good time, so as to plan and join. I think one aspect is that maybe if people are aware, then they will be coming in. So these are the sort of things that are coming out. Training, yes, we have seen that people are willing to mentor others, reach out to some of the senior colleagues and discuss and design some webinar programs that would lead to capacity building across that. Collaboration is key. I can build on what we have done. This is really, really excellent. I congratulate Seifu and the team for this initiative. When I saw it, I said that I have to participate actively in this just to really boost and give encouragement. And but as I said, some of the things also led that we couldn't mobilize more of our students to participate. So the survey is really, really good, and I think some of the one major aspect that came out also clearly is the issue of laboratories, capacity, analytical facility availability to hydrogeology across, and in such things you can easily map out and make capacity locations. This area you can get all your isotope analysis. Here you can do some heavy metals. These are recognized laboratories that so that people can easily and get conditions for accessing such facilities. Are they to be paid? Are there opportunities to do some aspects of it? And that will enhance collaboration further across African hydrogeology and things like that. These are just my few comments on this survey, and congratulations to all of you over there. All right, thank you very much.
Okay, thank you, Professor Goni. The next hand up is Hassan, Umar Hassan.
Okay, thank you very much. I am appreciate survey result presentations by Dr. Behailu as well as Edward Bam. The presentation is very attractive and summarize what we done yesterday questionnaire. As we understand from a survey presentation, especially on the qualification, most of them are masters and others are below masters, especially on the BSc and the diploma. My question is there any opportunity of the capacity building for the futures for those who have BSc or diploma? Thank you very much.
Okay, Umar, you've posed a question. Could you clarify, do you mean like a short course or do you mean master's training, because you talked about the capacity building?
Short masters and as well as short course, because for BSc master's chance, and for diploma also for degree chance, or other short course, both masters or short course.
Okay, this is going out a bit. Prof. Seifu, do you want to mention something about the short courses, if there's any kind of opportunity that is ready, or is it still in planning, please?
Yes, it is part of the post-2025 Africa Water Agenda, Water Vision. And then that area, Pillar 2, SO2 Strategic Objective 2, will particularly address that issue at Africa scale. So trying to source funding and financing for those kind of activities, and hope there will be finances of these kind of activities joining and supporting the program. Yeah.
Okay, thank you, Prof.
Okay, thank you very much.
Yeah. Any other questions? Or clarification? I think I see a comment from Gbewezoun Vinel. I think he is, this is addressed to you, Berhanu. This is about the slides. It says that you need to check. I think the last slide is some countries mentioned twice. So maybe that's just a comment to you. Okay, there's a hand raised by Piet, please.
Thank you, Lydia. Yeah, I think the survey results are quite interesting and some observations that were made. But I just want to also make one slight observation because I note that some of the countries that participated in the survey are missing in the category of individual countries. I think it could be where maybe there are few entries, maybe the overall result did not peak, but I think in further analysis, those where maybe entries were limited could be checked in the analysis. That's the small observation I've made, but otherwise they are quite interesting respondents. Thank you so much.
Okay, yeah, thank you, Berhanu. Behailu?
Yes, thank you, Lydia. Yes, thank you for raising the question. Like I said, it's a very quick survey. Definitely, there are things to complete, but in some of the slides, the countries presented are like top 10 countries, right? Not the entire one, right? To show only the top 10 for this presentation purpose. But if there are countries which are missed, but we shouldn't be, then definitely when we have more comprehensive digging and analysis, it will be complete. And thank you for the feedback.
Okay, yeah, thank you. Edward, your hand was up, please.
Follow up on what Behailu said. So yeah, we don't have all the data. I think people are still filling in, or some of the data came, and then after that, some were added. So we still need more data, and then I think people are still filling in. So we'll take all of that into account when we finalize the survey report. Thank you.
Yeah, thank you very much, both of you, for clarifying that. And since we are talking about capacity, Behailu, I was very interested in the figures that you had on the right showing the comparison of the various countries. Could you say which software you used?
Okay. I use R.
Okay.
R code.
Okay.
So all of the survey result that I have shown, I used R to produce that.
Okay. Yeah. Thank you for clarifying that. Yeah. Seifu, again, Prof.
Yeah, these are very beautiful pictures, illustrative. And then maybe in the comparison between regions and countries, I'm not sure, Behailu, if this has been normalized to the number of participants. Otherwise, yeah, so in a later stage, you'll have to look into the number of participants and how that would affect the outcome or the plots, the coloring pattern. But this is just a remark. But having said this, I think there are a number of insights that one can draw out of this. The earlier part of the survey from the abstract submissions that Edward did and the one Behailu led. Yeah, for instance, where are people getting their training from? Yeah, principally it is within Africa currently, yeah, particularly for master's training, and then PhD training, maybe international. And then which country? So the next question would be, did that countries that host most of the scholarship are also involved heavily in knowledge generation in Africa? So do we see that pattern? So who is providing most of the scholarship, and who is providing also most of the knowledge services and knowledge transfer? So I think there is these things that will further investigate based on the data. And then overall, it also shows there is critical mass of people to start networking and then also to start working together across boundaries. And then one of the survey question which has not been displayed, the result of which has not been displayed, Edward, is where have you, what is your country of origin and where are you currently working? So to see into mobilities across countries and between countries. So this will mean, for instance, a presentation by the presenter from Morocco on using AI and machine learning algorithms to predict water levels in Morocco, which can easily be enhanced and then scaled to the other regions. But that is only possible if mobility of professionals across the regions is enabled. So how can we make that possible? So these are the kind of things. I think a number of other insights will come from here, from the surveys.
Yeah,
and I'm looking forward to more detailed analysis of
Okay, let me mute.
Yes, more detailed analysis.
Sure.
So, in waiting for Mr. Rashid Mazibura to join us from AMCAR, and then once he joins us, and then we will go to the closing remarks. And then in the meantime, let's continue discussing. Back to you, Lydia.
Okay, thank you very much, Prof, for that clarification. I see some questions still on the chat, but there's maybe what is related to this particular session is Olivia, is it possible to share the survey link again? I think there is a request by Professor Cisse.
In the chat, so hopefully you should all be able to fill it in if you have not done so yet.
Okay, yeah, thank you for that. If you haven't filled in, or if you know some other people who are not here and they haven't filled, you can also share with them. Okay, then the others I think can come in the closing remarks. Any other related to this particular survey? Yeah, Edward, I see your hand. Please.
So, yeah. Can you hear me?
Yes, yeah.
Okay. Thank you. So, on the issue of the knowledge, our knowledge on water policy and things like that in the various countries where we're seeing huge disparities between the respondents from the same country, I think that is quite alarming. And I'm wondering how we can overcome that. For example, when I was doing my master's, we had a program which exposed us to the laws that govern the practice of the science in the area that we were training. So would it be something to recommend that, for example, the AU agenda, for instance, we're talking about revising syllabus either yearly or whatever it is. Would it be possible for us at certain point to recommend that some of these things be, integrated into the academic curriculum so that people who are training as hydrogeologists, they also know the policies that are available. They can analyze them from time to time, and then so that they basically have knowledge of it. And then also the vision that we have as a continent. These things directly integrated into the curriculum. That's the only way, from my perspective, that we can overcome the challenges. We can also have people who are in decision-making positions to take some of these things seriously. Because if you go to school, you are studying about water, and you don't know anything about water policy in your country, and you are going to be an expert on water, there's a problem. And then the continental level, you don't know what the policy is. I think my suggestion would be that we find a way to get these things to people who are the positions of kind of designing or monitoring education to embrace some of these things. It cannot be isolated. We can have water policy for the ministry, and then people who are learning to preserve water, protect it, and make sure we have water don't have any idea. It's a disconnect. That's just a comment to pass there.
Yeah, thank you, Edward, for highlighting that and the need of really connecting the science to the practice and the need to train students on the policies which govern the resource that they're working on. Prof, I see your hand up. Professor Seifu, please.
Yes, just a follow-up on what Edward just said, and then also comparing it against what yesterday and before yesterday the keynote speakers like Alan MacDonald and Grant Ferguson and Dan Olago had to say about the role of data, the role of information, the role of putting our feet in the ground. Nothing will, if I will use the word that Alan used, nothing will replace that. Nothing will replace hydrogeology and field hydrogeology. And having said this, and then looking into the various presentations and the survey results, there is a kind of emergence of GIS, which is not bad. Overlay analysis, GIS, overlay analysis, and also isotope hydrology, chemical traces, which should be used along with feet on the ground, or to support work that is come from feet on the ground. It should not go in alone. I think that taking that note of what is currently happening and what the experience is saying, I think some of our curriculum will have to be adjusted to the needs, not only to the ease of doing things. One can produce beautiful maps, GIS, remote sensing. There is a number of huge skill in those areas, but it will answer part of the question only. And then I think in that regard, skills to supervise students, supervisory skills in African institutions, that is super important. And then this is what we'll put into our recommendations to the AMCAU's post-2025 agenda. So I think there are curriculums, there are institutions, critical mass of people. Now it's about enhancing the quality through supporting supervision, student supervision. It's just a reflection, maybe it's personal opinion as well. Thank you.
Yeah, thank you, Prof. Seifu, for highlighting that. And I think that is the beauty of this Pan-African Congress, that we are able to identify the gaps and what really we need to act on within the continent, or the recommendations that can be able to push the agenda or proper management of the groundwater resources. I see a comment for you, Edward, on somebody writing the water policy regulation, so please attend to that. And then Piet, your hand is up, please.
Yes, thanks a lot. I just want to make a reflection on what Edward said regarding the knowledge of policies and strategies, which is quite good. And I think I agree with him entirely. But I'm reflecting again on perhaps how the question was framed in the survey, and maybe can be a room for improvement. Because I think the intention was to specifically look for the strategy that speaks to groundwater, if I remember. And you might find that it's a tricky one, because in some countries, is very specific. You will have a groundwater strategy as an example for the country. While in some, it may not be so, but in the policy or whatever plan, it might be reflecting groundwater. So depending, I think, as you said, Edward, depending on the experience, one would not be able to distinguish between the two in terms of if there is a chapter in this general policy on groundwater, this is what we are really looking for. So it's, for me, you are right, but it also brings in a question of interpreting what we are trying to get from the participants, and I think it also may also present itself as a gap, for example, in most countries, because if there isn't any specific policy relating to groundwater, it actually means that groundwater is still subsumed within the general water management, but there is still a gap. And I think our aim is to bring groundwater out from the invisibility to visibility. So it's quite an interesting discussion, and I like the way you put it. So having a training discussion and modules on these issues is quite pertinent going forward, and I completely agree with you. Thank you so much.
Thank you, Prof.
Yeah,
Well taken.
Yeah, thank you, Pierre. Let's have Behailu. I see your hand up, please.
Yes, thank you, Lydia. Just a follow-up to what Prof. Pitt just said. I understand that some of the questions can be subjective, and as a result, variation in responses is expected. Let's say one of the questions under category 7 is the extent of hydrogeology integration to groundwater governance. So to what extent is hydrogeology integrated in governance can be subject. There could be some subjectivity to that. So we don't expect everybody to respond the same way. But some of the questions like policy, the policy question is like clear. It cannot be subjective. So it says, is there groundwater policy in your country? So you expect yes or no, right? So there is no any gray in between. Of course, if we are splitting hairs, let's say in Ethiopia, the water policy is integrated water resource management, and the groundwater is put into that framework. So there is no any groundwater policy, but there is integrated water resource policy, so groundwater is part of it. So that would be a discussion. But I would mostly expect a yes and no response. But even in that regard, a number of countries, they respond differently. So the knowledge, the exposure to that, then what Edward was saying becomes more relevant. So we have to know our policy, right? So the ultimate thing is not just a scientific fantasy, right? It's something that we want to do on the ground to the community. So unless we get that knowledge, how the country operates in terms of policy and strategy, then it's going to be difficult. So I think in that regard, there are things that we really need to think of and how we familiarize our policy and the strategy of that respecting country. Thank you.
Yeah, thank you, Behailu, for clarifying that on how the questions were framed and how could be subjective as well. Yeah, do we have any other?
And then those of you who are not member of the IAH, if you simply Google IAH and then IAH.org, and then you'll find the link to membership.
Okay.
Edward?
Edward?
Yeah, on the survey, we still need more data. So we plead with everybody to distribute a link and then encourage colleagues to complete it. Probably, I don't know whether by the end of next week, would that be okay with everybody? I'm talking about the team. Prof. Seifu, do you think by the end of next week, we should still continue collecting data till next week? Because I'm thinking we need some representation. So
Yes.
if we can
I think we must continue, Edward, as you rightly said, we must continue gathering more data from more people. And then make it available widely to policymakers, decision takers. And then the aim is also to make it part of an international publication, because it's very critical information that policymakers and partners would like to see. And we'll continue, we'll be pushy, and apologies if we push you to to fill the forms. It's for the common benefit of everybody and all of us. So I don't see Amkau. I don't see Amkau here. And then maybe I'll close, if you allow me, this meeting. So by saying the following, it has been such a successful gathering with nearly 175 participants, and out of which 27 countries from Africa participated, and around 16 countries internationally participated in this event. And then we didn't expect this much people attending, some of them for the whole day. And so we started off in the blind, and we didn't know what and how it's going to turn out. And then there are a number of lessons that we have taken from this. Number one is on the format. I think the online format is still promising, and before moving into face-to-face, for sure we'll go for a second one. But the second one, whether we go by online or face-to-face, it will depend on funding, money availability, but online is also very promising to exchange knowledge and stay connected. Thank you so much all for attending this successful event and inking your name into the first Pan-African Hydrogeology Congress. So we were meant to issue a resolution, but I think, again, for representation and reaching out as many as possible, I will give us only the sense of what this resolution is about, and then circulate it again among us for comments before issuing it formally to our network and partners. So these are like the contents or the highlights of what this resolution would be. Number one, we recognize our successes, and then through this congress or conference, we have shown that there is critical mass of hydrogeologists in the countries. And then this is a strong foundation upon which to build a vibrant professional community that can address pressing water challenges in the African continent. We also acknowledge gaps and concerns, and then these gaps and concerns are the level of research. Also individually and in many places have reached such an excellent level, even to making global impacts. The balance between quantitative and qualitative research is we need to work on it. And then in terms of research on solving real-time problems, and then setting and leaving behind us some of the research which are quick fix and quick to obtain results. So as hydrogeologists, we recognize our role in getting to the field and getting data from the field and working with that data. And then also in the era of emerging machine learning, the collected data can be interpreted using these approaches. And it's time to embrace this and drop and maybe leave aside or the other approaches that we have been following. So there are areas of needing strengths in terms of research and our supervisory capacities in Africa. And then commitment to collaboration and knowledge sharing, that has been widely discussed. And then we all commit to this. And unfortunately, in the history, I would say we are sitting at the juncture where the continent is aiming to have a vision on groundwater. So we want to be part of this vision. So we show our commitment to collaborate among ourselves and with the continental and regional bodies in Africa. And then we also call for governments and partners to invest in building the next generation of hydrogeologists. As you can see from the surveys, so most of our graduates, the labor force, are young graduates, the last 10 years, needing continuous capacity building and continuous support. And then we call for more investment on enabling this young dynamic workforce to become local and regional international players. So, and then as a need to also strengthen education, research, and mentorship. In the survey, we have seen some very good progresses, as well as also worrisome situations like the teaching methodology, supervision, and then focus on some areas and replicating it across, while it can be done at once across the continent, for instance. So I think that area would need strengthening, and then we intend to collaborate and work on the tertiary level education and collaboration. And on data and knowledge as public goods, the tendency, as also highlighted in the survey, is to share to peer-to-peer data. While we encourage this to continue, because data is not just the numbers and the figures, it is also relational. It's about people relating to people. We recognize Africa's strengths in that regard, but we'll also need to value platforms for data sharing in the continent using the regionally enabled platforms. And then I think looking forward, we'll continue to engage in this kind of event. The second event will happen in about 1 year time, and then the mode of it will be communicated to you. So all in all, I would say it was such a well-deserved event, and I thank the active, dynamic organizing team. I don't have enough words to thank everybody, Edward, Cynthia, Behailu, Lydia, Piet, Nawal, Maha, Tony, Olivia. Did I forget anybody? Yeah, all diligently working, Udi from South Africa. all diligently working and then making this conference a successful one. So we aim to publish book of abstracts, and all the abstracts that has been submitted will be published, and then we'll get back to you on the YouTube video on the recording and sharing that records. And I hope you encourage Sainabu, I forgot Sainabu. We all encourage networking among ourselves, regionally, locally, and let's continue engaging. Thank you so much on behalf of the organizing committee and as Vice President for the IAH Sub-Saharan Africa chapter. I say this conference is adjourned. Thank you so much.
Thank you.
Thank you, Prof.
Thank you.
Thanks, Seifu. It's been a great few days. Thanks, everyone.
Thank you. Thank you.
Thank you so much. Thank you.
Thank you, Saibu, for your able leadership.
Thanks,
Thank
Tony.
you, Professor Seifu.
Thank you,
Thank you.
Seifu, and
Thank you
all
so much.
the
Thank you.
organizing committee members and participants. Thank you so much.
Thank you.